Yes, sir.
Yes, sir.
Hello,
Yes,
am I
sir.
audible?
Yes, sir.
Sir.
No, sir. No, sir.
Hello, am I audible?
So you will not
No,
audible.
sir. Yes, sir. Yes. You are audible, sir.
Sir,
Sir,
you are
you are audible, sir.
audible.
Yes,
Audible.
sir, you are audible.
I'm not the teacher. I'm just confirming that I'm audible or not. I'm a student. I'm not a teacher. I think the teacher has not come yet. I'm not a teacher.
भाई स्कैम क्यों कर रहा है? टीचर नहीं है वो ऐसे ही बोल रहे हैं.
Hello. Yeah.
Good
Sir,
evening.
mute
Good evening,
everyone.
sir.
Who else is speaking?
टीचर नहीं है वो टीचर.
Sir, please mute all.
Okay. So hello. I'm hoping think I'm audible to all of you. Can you confirm on the chat box? Okay. Yeah. Okay. All right. Yeah. So agenda for today's session is like anyway, we are going to revise the content of week 1 and week 2. Okay. So I will revise the content mainly like which is important to the your exam point of view. Okay. So we'll not go in that much depth, but yeah, we'll try to cover the concepts of, I mean, mainly we are going to brush up on the concepts of week 1 and week 2. All right. Okay. Hope that is fine to all of you. Okay. So also I have a question paper from the last term. Okay. Then I will try to discuss the questions from those topics which we are going to discuss. Okay. So let me share my screen. Can you see my screen? Okay. All right. Great. Okay. Yeah. So like we are going to discuss the mainly we are going to revise the concepts of week 1 and week 2. So we will start from in week 1, what is, so we will start from what is statistics. Okay. And then we'll see the branch of statistics, descriptive and inferential. Okay. Then we have seen in week 1, while we were discussing week 1 content, we have seen the types of data, and also first of all we saw, I mean, there are two, I mean, for different kind of scenario we have like we have seen categorical data, types of data, and we will see numerical data. Okay. And after that we'll see what is the time series data. I mean, we'll cover the what is the difference between time series data and cross-sectional data. Okay. And then we'll see structured data. Okay. And then we will study about what is the difference between structured data and unstructured data. So basically these kind of concepts, you can get the questions related to these kind of basic concepts. Okay, like suppose some scenario is given to you, you have to identify whether it's a time series or whether it's a continuous or something like that. Okay. Then we'll see what is, we'll try to see that cases and or you can say cases or observations, then variables. Okay. I mean, these all topics mainly we will start. Okay. So I'm going to start from the very first topic called statistics. Yes, you know what is the statistics? Statistics is nothing but it's art of learning from data. Okay, so basically we'll see, we have seen statistics has two parts. Okay, first one is descriptive statistics, second one is inferential statistics. Okay, and in descriptive statistics, what we are doing, basically we have seen lots of times. So descriptive study is nothing but it consists with when we are interested only describing or summarizing the data set. It doesn't matter whether we have sample data set or population data set. I will define what is the sample and population right now, but it's a mainly we are going to, I mean, mainly we are interested in whatever the data set I have. I have to describe that data set. I mean, nothing more than that, right? So let's say, give me a second. Suppose I have a data set of screen. Okay, suppose I have data set of this, some uh, marks of, let's say this, suppose this is the marks of 8 students. Okay, then what else I can do basically? So what are the things I can describe from this data set? So I can say, yeah, average marks is, let's say, 68. I can say, maximum marks is, you can say 72. Minimum is, I think, 65. So basically you can plot, histogram and some visual representation and all. So thing is that whatever the data set you have currently, you are just going to describe that data set. Okay, suppose you have let's say marks of some, let's say not this won't be marks, so let's say 78, some 28, some 90, or 67, 89, or let's say suppose this you have marks of 16 students. Then you are going to describe this data set. So it doesn't matter whether you have whatever the data set you have, you are going to just simply describing that data set. You are just going to explore that data set. Okay, nothing more than that. Okay, so and what we are doing in inferential, so we are going in inferential, as you can say, it's a inference, right? You can focus on the word called inference. So we are going to conclude, okay, or we are going to make some inference from the data. Okay, so before this, we will see what is the sample and population. Okay, I'm hoping this some rough idea is okay clear to all of you, right? So let me give you some idea about population and sample. So what does population says, so population is what? Is nothing but collection of, or you can say total collection of all the items in which we are interested. All right. For example, suppose you are interested to know, average speed of a bike, particular bike, let's say Splendor or something like that. Then what will be your population? Then population, let's say you are interested in a particular, or let's say you are interested to know the number of Splendor bikes sold in a particular state. Then what you will do? You will go all the showrooms and you will take the data of all the Splendor bike which has been sold, right? So that will be the collection of all the items in which you are interested. That will be your population. Okay, and that can be anything, 1,000, 10,000, whatever. It's doesn't matter. And what is the sample? Sample is nothing but it's a subset of this population. Okay, so this is the sample and this is the population. And one more thing you have to keep in your mind, my sample should be good representative. Okay, so good, what do you mean by good representative? Suppose I have population like this. Okay, let me use some different color here. Let's say I have some balls of various color. Let's say this red I have. Let's say some yellow or not yellow, violet or some black as well. Okay, suppose this is the collection of balls I have, and I took a sample. Okay, and I took a sample of one black and let's say one green or something like that, one more, let's say. So you can see here my sample, can you confirm that whether it's a good representative or not? Now, no, right? This sample is not a good representative because it should include elements of everything, right? This brown color, red color, and all. Sir, this is the sample. You can't deny this is not a sample, but this is not a good representative, right? So this thing you have to keep in your mind. Your sample should be the good representative for your population. Yeah. So let's come back to this inference part, right? Inferential statistics. So what we are doing in inferential statistics, so we are going to make a conclusion, or we are going to make an inference from the sample data about the population data. Okay. For example, let me come back to this example. Okay. Suppose this is the marks of some 15 students from let's say from school. Okay. You went, you are an analyst and you want to know, yeah, what is the performance of students in this particular school. Then what you can do is you went in that school and you just randomly picked up sample data of marks for this 15 students. And then what you have done, let's say you calculated the average marks. Okay, let's say what is the average of this. Okay, don't worry about this Google Sheet. Questions won't come in exam Google Sheet. I'm just uh, doing just for okay, so that you can get the idea. Okay, so average is, let's say, this 71 approximately. Okay, then in inferential statistics, what you are going to do based on this data set, right? This small sample data set, if you are making conclusion like average marks of I mean average marks of students in that particular school is 78, right? Then this will be inferential statistics because what you have done, you took a sample of 15 students, right? Marks of these 50 students, and then you got average marks as 71, right? Then what you are doing now, you are making conclusion average marks throughout the school, average marks of all the students in this particular school is 71. Then what you are doing, based on this sample data, you are making the conclusion for this population data. Okay, so in inferential statistics, you can see there is a factor of chance, right? You are making something, right? It may be correct, it may not be correct, right? There might be a problem of accuracy. Those kind of things will study later. But key thing is you have to observe here, or you have to focus in descriptive statistics. Whatever data set I have, whether you have data set of this 15 students, or whether you have data of, let's say, this some 7 students, or whether you have data set of this 4 students, whatever data set you have, you are just describing that data set. Okay, nothing more than that. So similarly, we can make conclusion we can make a okay. So can you confirm me on chat? Descriptive statistics I can perform on sample as well as population, right? Correct. Correct. Because descriptive statistics can be performed on sample and population data. Okay. So population data is nothing but whatever the total collection of all the elements, right? Now, in inferential statistics, can I perform inferential statistics on population data? No, right? I can perform inferential statistics only on the sample data set. Okay. I think this rough idea is okay to all of you. All right. Okay. This descriptive, yes, inferential statistics we can perform only on sample data set. Okay. So you can take another example also. Let's say suppose there is a university. Okay. In that university, let's say there are some 4 departments. Okay. Let's say one department is CS, another is, let's say, electronics, and another is, let's say, mechanical, or another is, let's say, some humanities or something, some other. Okay. So there is a university or a college, and then what you are interested to know, performance of the students in that college or something like that. Then what you can do? Suppose you took a sample of some, let's say 250 students, for example. Okay. You took a sample of, let's say 250 students, or let's say 50 students for simplicity, let's say 50 students. Right? Suppose you want to know the performance of a student in placement during placements. Then this is the sample. Okay. Okay. Now, suppose you took this 50 sample students of this 50 samples only from CS and let's say electrical department. Okay. So now, can you tell me this sample is a good representative or not? No, right? This sample will not be good representative because you have taken a sample of 50 students only from CS and electrical. You have ignored this mechanical and humanities department, something like that. Now, suppose what you have done, you did your analysis and all, and you found average annual package of this students is, let's say, 10 lakh. Okay, for example. Then what you are going to do? Suppose you came to me and you gave me a report like average annual package in University A is 10 lakh. Okay. Then what you have done here? Based on this small data of, based on this sample data of 50 students, you made a conclusion for this population data set, right? I mean this uh, for all the students of that particular university or college. So this is something called inferential statistics. Okay, fine. Okay, so after this, we will move to the topic called, let me explain. Okay, let me see whether we had questions related to this or not. So this is the last term question paper. Okay, we'll share with you or TS will discuss with you. Okay, now you can see this question. Okay, this question. So that's why I'm saying you have to be clear with your some just basic concepts. Can you see the questions and anyway answers are already there. Like to ensure the accuracy of conclusion drawn through inferential statistics. So what are the options should be correct? Sample should be a good representative of the population, right? You know, and sample should be randomly selected. Would you agree with me? Right? Yeah, randomly, right? Suppose you should select the sample randomly. If you'll take by your intuition, you are going to give wrong report, right? Okay, all right. So next is something I will discuss that questions later. Okay. Now next is something called, I told you we are going to discuss data. So now first we will see types of data. So it's called structured data. Okay. And then we'll see unstructured data. All right. So what is the structured data? As the name, if you will focus on the name, structured data means these kind of data always have a predefined format, or it's always be in predefined manner, or you can say it will be have standard format. Okay. If it's in standard format, it's easy to search the information. All right. And while unstructured data, it's not in it's not in any predefined form. Right? It doesn't have any predefined manner. It's always in its native manner. Let's say, for example, and I will say, no, YouTube comments on a video, right? So YouTube comments will not be having any predefined manner, right? It will not be having. It will not have any structured way, right? It will not be having be in any tabular form or something like. It will be in its native format. So if it's very text heavy data, or it's not in tabular form or something like that, then it's very difficult to analyze any kind of information, right? So from unstructured data, it's very difficult. You will require more effort to analyze any kind of information. Okay, for example, I'm going to just take a I will take a minute. I will write something. Maybe that will give you idea. For example, suppose I'm saying, let's say I will take a very simple example. Suppose Ankit is a student and he is in class 12 and his marks in class 10 was, let's say, 98%. Then let's say Sunil is a student and he is in 11th and his marks in class 10th was, let's say, 92%. Then again, suppose some another student, Suman is a student, okay, and C is in 12th and her marks in class 10 was 95%. Okay, so at the first chance, can you tell me whether this data is structured or unstructured? Okay, unstructured, right? Correct. Because this doesn't have any predefined manner or any standard format. Suppose I have asked, tell me the marks of uh, let's say Sunil in class 10, then you have to go word by word and you will see, then you will get, yeah, Sunil scored 92% in class 10th, right? So what is the case here? If you have unstructured data, right, you will require more effort, right? It's in native format, not in any predefined manner, right? While if I will convert in structured data, let's say I'm saying, let's say name of student and let's say class and marks in 10. Okay, then it's very easy, right? So suppose Ankit 12 and 98%, then Sunil 11 92%, Suman 12 95%. Okay, now if I will ask to from this data, what is the marks is Sunil scored in his class 10, you will simply within a second you will tell me he scored 92%, right? So now this data is structured or unstructured, right? This will be structured data, correct? Fine. So because it has a predefined manner, right? It's in a standard format. So it's a very simple thing, right? So whenever by the name suggests structured means it will be in any standard format. Unstructured means it will not. It doesn't have any predefined manner. Okay. Now, so I will move to the cases and observations. Okay, what is the definition of cases or observations and variables? Okay, sometimes people have some confusion. I will try to cover these things. Okay, till now, till structured, is it clear to all of you? Yes. No? Okay. Oh, fine. So what is the, I will take example. So case, if you see the definition of cases, right? So case is a unit, right? So it's a unit, no, for which data is collected. Okay. So two or three things we have to keep in mind. And row represents the cases. Okay. And cases should be unique. Okay. And what is the variable? By the name suggests, variable means a variable is something which varies. Okay, and always column represents variables. Okay, all right. So I will so you have to you have to just keep these things in your mind. Like case is a unit for which your data is collected, and row represent the cases, and cases should be unique. Okay, for example, I will take the very uh, basic thing. Okay, let me go to the portal itself. Okay, maybe I will take some example from there. Okay, uh, okay, not this one. Let me take some another example. Maybe not here. Okay, so what you can see, let me take this one. Okay, so I told you, right, what is the variable? Variable column represents the variable. So here you can see time, column time, first column. Second column is temperature, degree Celsius. Third column is relative humidity. Okay, so you can see under time things are varying, right? Values are varying. Okay, let me draw it so that it will be clear for you. Let me draw some other example. Let's say name. Okay, class. Okay, and mobile number, for example, and let's say state from where they are belonging to. Let's say ram, age in, let's say 10, mobile number, let's say 9828 something, and let's say state, let's say he's from Delhi. Let's say Suman, 11, 7928 something like that. Suppose he's from Haryana. Okay, and let's say I'm taking some another name, Sunil, let's say 10, 9853 something like that. Suppose he's from Chandigarh. Okay, suppose some another, let's say Rahul, no, 12, some 69, and this, suppose he's from uh, any other say from Chennai, for example. Okay, all right. So as I told you, right? So case is a unit for which your data is collected. So what you have to observe here. So here RAM is a case, right? First of all, row represents the cases. You have to go to the each row, right? You can check each row. So these are the row, right? So you can say for RAM, we are collecting the data, right? We have collected data. Yeah, he's in class 10. His mobile number is this, and he's from Delhi. Suman is a case. Okay. And for Suman, we have collected the data. She is in class 11. Her mobile number is 7928, and she is from Haryana, so on and so forth, right? So thing is that you can see row represent the cases, and all name are unique in this case. Okay. Thing is that you have to observe. First of all, I told you that cases should be the unique. For example, instead of this Rahul, I have another Ram. Okay, suppose I kept another Ram. So why I'm focusing on cases should be unique. Suppose I ask you, tell me the mobile number of Ram. Correct. Then you will be confused which RAM I'm talking about, right? Whether I'm asking the mobile number of this RAM, or whether I'm asking the mobile number of this RAM. Okay, so there should be something which should be unique. So for example, suppose there is a part of roll number. So let's say 0 1 for a Suman, let's say 03, and for Suman 05, let's say, suppose these are the roll number, right? So you can simply see here roll numbers will always be unique here, right? Okay, so there, if you have been given any tabular data, right, then there should be something which will be unique, and you have to identify that will be interpreted as a case. Okay. Yeah, so yes, one inferential is something when we are going to make conclusions from sample data to a big population data, okay, for a large data set. While in descriptive, whatever the data set you have to just give the, you have to basically you have to explore that data. Okay. Now, what about here variable? So as you can say, name is a variable, right? Class is a variable, because I told you, right, column represents the variable. So each column, roll number. So you can say under this, I told you what is the variable which varies, right? Under which values are varying. You can see values are varying, right? Under name there are different names, right? Class also different varying, right? Similarly, mobile numbers. So thing is that variable is something which is varying. So you can see this name is a column, roll number is a column, class is a column, right? Mobile number is a column. Okay, all right. Is this fine? Okay, yeah, ram is a case, but if here you will not say ram is a case now, because you can simply see when all the names are unique, then you can say it's a case. Otherwise you have to take those case where it's a unique. So here you can't say ram is a case because it's a repeating, right? Even though you can't say suman is a case, because here names are repeating, names are not unique. So you have to see that thing which is unique. Okay, so basically first of all see which row and see which is the unique, if that is the unique, and case is a unit also for which your data is collected. So here you can simply interpret for roll number 1 you are going to collect data, right? For roll number 1, what is the name of the student, in which class, mobile number, and his or her state. Similarly, roll number for roll number 3, name of the student, and basically it's the unit for which your data has been collected. All right. Okay, yeah. No, mobile number can't be a case here. Okay, so because for mobile number you are not going to collect the data. For roll number 1 you are going to collect data. You can't say for this mobile number roll number is 1. No. So you have to keep these three things in your mind. Case is a unit for which your data you are going to collect the data, and first of all see row represents the case, and see for which unit your data has been collected. Cases should be unique. Okay, so for roll number 1 you are going to collect data, not for a mobile number you are going to collect data. I hope this is clear to you. Okay, 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 all right. Yeah, mock we will discuss, we have another session on Friday, so don't worry about mock. Friday is the due date. Till then you have to attend the mock. Okay. Now, I will move to the topic. Before going to that question, let me see the question. Okay, let me discuss some topic, then I will move to the previous year question paper, which we have discussed. So we have seen this types of data, structured and unstructured. So mainly we have two another things, right, for data. First is categorical data, another is numerical data. Okay. Under numerical data, we'll see another two categories, which is called, discrete, and another is contiguous. Okay. Now, what is the categorical data? You have to keep in mind. So categorical data is something, on categorical data, categorical data is always in qualitative in nature, not in quantitative. And main thing you have to differentiate for categorical data, we cannot perform any meaningful mathematical operation on it. Okay, even though categorical data are in numbers. So if you have categorical data in numbers, so that numbers you can use only for labeling or coding that categories, right? You can simply interpret from categorical categories, something like that. For example, let's say I will take very simple example, gender. Let's say gender, we have two categories, female and male. Suppose I'm taking these two. So you cannot say, right, female plus male equal to something like that, or you can't find female is greater than male, something like that. This is meaningless, right? So if you have categorical data, you cannot perform any meaningful mathematical operation on it. even though these are in numbers. Suppose I'm saying I'm going to code female as 1, male as a 0, for example. Then you cannot say 1 plus 0 equal to 1, right? Mathematically it's correct, but here it's doesn't make any sense, right? It's a meaningless here. So here, because here 1 represents a female category, 0 represents the male category. So you should be you have to take care of these things. Okay, so categorical data is something you cannot perform any meaningful mathematical operation. All right, what do you mean to identify group mentorship in category? What do you mean by I'm not getting your question? Can you repeat? Sakshi Soni. Yeah, qualitative attributes means basically, like, you can say whatever the thing, like, say qualitative attributes is can be anything. Like suppose you are going to make the categories based on, let's say, hair color. Okay, you have kept some person based on let's say you made a category based on some hair color. Let's say you have created a category with black hair color and brown hair color and white hair, something like that. Okay, so here you can say also see hair color will also be and will also come under the categorical data. Okay, tell me what about jersey number of players, whether it will be categorical or numerical. Let's say 7, 13, 98, something like that. It's categorical, numerical. Categorical, right? No, no, not numerical. Someone wrote numerical. So it's a categorical data because you cannot perform meaningful mathematical operation, right? So this see 7, 13, these are the fixed kind of it denotes for a particular player, right? It doesn't, you cannot say at 13 player 13 is greater than player 7, right? You can't say something like that. So you have to take care of these things, so whether you are able to perform any meaningful mathematical operation on it or not. For example, phone number. Okay, so phone number will also comes under the categorical data. Okay, why? You can't say addition of your contact number or my phone number is same as someone else or something like that, or your phone number is greater than my phone number or something like that. Okay, so if I'm not able to perform any meaningful mathematical operation on a data, that means it will comes under the categorical data, even though those are in numbers. Okay, so you have to take care of these basic things. For example, okay, let's move to the, it's clear, right, all of you? Roll numbers is a case, yeah. Okay. Okay, fine. Okay, now come for the numerical data. So numerical data is what? I can perform, means see, it's opposite to categorical data. In categorical data, we cannot perform meaningful mathematical operation. While for the numerical data, I am able to, I can perform meaningful mathematical operation. Okay. So basically, numerical data is always quantitative in nature. Okay. So for example, let's say marks. You can perform meaningful mathematical operation, right? You can add 2 marks. You can calculate the average of the marks. You can find the maximum marks. You can simply say, yeah, my marks is twice. Yeah, yeah. Comparison is like, it's not about when you will see ordinal data, you can compare. Okay, it's mainly about whether you are able to perform meaningful mathematical operation on categorical data or not. Okay, here. So marks is something you can perform meaningful mathematical operation. You can calculate the average. You can say, yeah, my marks is a half. I scored let's say I scored 60, you scored 50, so mine is 10 more than you, something like that. So I'm able to perform meaningful mathematical operation. So key thing is, under numerical data, we have two things, right? First, called the discrete data. Okay. So discrete is something I'm able to count, and it take distinct values. If you plot real line on a real line. So to keep in mind, it take distinct value. It cannot take uh, any value between interval. For example, count means suppose I'm taking let's say number of laptops in a shop or something like that. Okay, so this is something what it's a countable, right? You have to count. Okay, let's say one laptop, 10 laptop, or 12 laptop, or 15 laptop, something like that. And if you draw a real line, right, then it will take distinct value. Let's say this is 1, suppose this is 10, this is 12, this is 15. So it will take distinct value, right? This value, this value, this value, this value. It is not going to take any value between interval, right? Between this and this, between this and this, between this and this, something like that. Okay. So to keep in mind, discrete data is something which is countable, and it will take always distinct value on a real line. Let's say another example. Suppose I'm saying no number of pages in a book. Okay, this is also discrete data, right? You can count, right? Let's say 200 pages, 250 pages, 300 pages, let's say 320 pages, something like that. And if you will draw a real line, so it will be, let's say, 200, 250, 300, 320. So it is going to take distinct value. You can see which I'm highlighting here. It will take distinct value. It is not going to take any value in between these two intervals. All right, clear? No, it's not about decimal or see, discrete data is not something you can't say it's not in decimal. Okay, it can be in decimal. So the key thing is you have to observe whether it is going to take this any value in between or not. Let's say suppose there is a data which is possibly take, suppose there is a variable which is going to take only value 1, let's say 1.5, 2, 2.5, 3, 3.5, something like that. Okay, so this is, suppose I'm saying I have x, and this x is going to take this only this value. Okay, so this is the discrete data, right? So key thing is you can count first of all here, and second thing, it is not going to take any value in between, any value in between of any interval, right? It is taking distinct value, this value, and then this value, and then this value, and then this value, and this value, and this value. Suppose you have a coin of 1 rupees, 2 rupees, or something like that, and you have coin of 50, have you seen that 50 paise and all, and I ask about 1.5 rupees. Okay, then you can do like this. So thing is that it's not about decimal and all. You have to keep in mind whether uh, it is going to take distinct value, or I'm able to count, then it will come under the discrete data set. All right. Voice is not clear to all of. Is it okay, right? Yeah. Is it fine to all of you? Yeah. Okay. Fine. Okay. So now this is comes under the discrete data. So discrete data, I told you that is something which you can count. So let's who is this? I think rhythms. You shouldn't do like this. Okay. Okay. So next one is called continuous data. So as the name suggests, right? Continuous means with occurring continuously, right? So continuous, you cannot count. Okay. While you have seen discrete data, I can count. Continuous, you cannot count. But continuous in data, in continuous data set, measurement is involved, right? And it can take any value between an interval. Okay. And it's opposite to discrete, right? So I told you, in case of discrete, it is not going to take any value between any of the interval, right? While in the continuous, it is possible. Also in discrete, we are able to count, but in continuous, we are not able to count. We have to measurement the things. For example, let's say I'm saying height of a person. Okay, so height of a person is what you cannot count, right? You have to measure. Let's say you say 5.4 feet, or some 6 feet, or something like that. Okay, and it can take any value an interval, right? So here, what is the thing? Height is something what you to measure, right? You to measure in inch or you to measure in feet. Another example is very standard example, weight of a person. Okay, so weight of a person, let's say I'm saying 68 kilograms. So weight is what? You do something you to measure, right? You cannot count the weight. You to measure. Let's say you will say 72.5 kilogram and 30 kilogram and so on, something like that. And if you draw a real line, okay, suppose this is 30 and this is 68, for example, then it can take, suppose you took a data of some people, then it can take any value in between, right? Between this interval and this to this interval, something like that. So you have to keep in mind that in discrete, it is not possible, right? It can't take any value. It will take only distinct value, right? This, highlighted one, which I'm highlighting here. It will take only distinct value. It is not going to take in between. And because this is countable, that's why it's taking distinct value. And here measurement is involved. Let's say I'm saying, time taken to you, from reaching from, is it low wise to all of you, or is it okay? I think, correct. From my side, it's fine, right? Okay, fine. Yeah, thank you. Okay, so for example, so I'm saying you took a time. Suppose time taken by you, from your home to, let's say, your office or your school. Then whether it will be discrete or continuous? Tell me. Continuous, correct? Yeah. So something like that. So let's say I'm saying, speed of a vehicle. So speed of a vehicle you have to measure or you have to count. It's a continuous, right? Yeah, I have to measure. So speed of vehicle you have to measure. Let's say you will say 42 kilometer per hour or something like that. Okay, you will say 50 kilometer per hour. You cannot count the speed. You have to measure the speed. Okay, I'm hoping till now it is fine to all of you. All right. Yeah, continuous can take any value in between. Suppose I have a data set of, let's suppose this is 42, 50, and suppose I have interval of this 40 and 50, 40 kilometer per hour and 50 kilometer per hour. Then you can take a data and it can take any value in between, right? Something like that. It can take in between means, suppose I have interval of this 40 to 50. It can take any value 40.23, it can take 40.93, it can take 40.57, it can take 41 point something like that. While in discrete, it will take only this value and only this value, not any value in between. But in case of continuous, it can take any value. All right, clear? Yeah, okay, fine. This is clear to all of you. Then let me explain something called, another type of data, which is called, time series data and cross-sectional data. Okay. So time series data is, as the name suggests, you can simply see the data, which you can simply say data recorded over time, right? And here data recorded at same time. Okay, I will take example. Maybe that will give you a clear idea. So time series data and calls, like whenever you are going to collect the data over time, right? So here time series, okay. So don't think time is always here in only in minute or hour. Time can be year, time can be here seconds, or time can be month, or time can be in terms of days or weeks or something like that. Okay, I will take example. Maybe that will give you an idea. Suppose uh, I let's say suppose there is city Delhi. I took I recorded the data of temperature on let's say Sunday, Monday, Tuesday, Wednesday, Thursday, or let's say Friday. Okay. So for I collected the data of temperature in Delhi for these different days. Okay. So let's say there is X degree Celsius, Y degree Celsius, some temperatures are there. So what you are doing here, if you see here, we are recording the data over the time, okay, at the different times, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. While the city is the same, right? Place is the same, but time is the different. Okay. For example, let me take for cross. So this will be time series. All right. Okay. What about cross-sectional data? Means suppose on Sunday only, right? We have collected the data in different city. Let's say Delhi, Chennai, let's say Punjab, Haryana, or something like that, some other city. So what you can see here in cross-sectional data, right? In cross, what is the case? We are going to record the data at the same time. So what is the time here? Sunday. At the same time, at a fixed time, we have collected the data in Delhi, data of temperature of city Delhi, then of Chennai, then of Punjab, then of Haryana. Okay. So here you can see time is the same. While in the time series data, time was the different. Okay. So this will be, you will say this is the cross-sectional data. Okay. So let me take another example. Suppose no, you are an owner of a company, so you wanted to know the sales distribution of let's say product X in 2020, 2021, 2022, 2023. Okay. Sir, what you are going to take? So suppose sales distribution 2020 is X percentage, Y percentage, J percentage, and W percentage. So what you are doing? So this will be time series or cross-sectional data? Time series. Great. So why? Because we have collected the data on different time, right? And for different years. So this will be, I'm just writing TS for time series data. Okay? Now, suppose at the same time, suppose you are an analyst and you want to know the sales distribution of product X in 2022, okay, for different companies. Okay? For example, in 2022, suppose you are going to see in, let's say, company A, for company B, company C, company D, company E. Okay, so this, let's say, something like that. Percentage can be anything, right? Can vary, whatever. So thing is that you have to observe here, you can see time is the same. So this will be, I'm writing CS for cross-sectional data, TS for time series data. Okay? I hope this is clear to all of you, right? Okay, yeah. So this is cross-sectional data. Okay, now if you see, uh, can you give the answer for this? Which statement is true? So the gross annual income for each of 1,000 randomly chosen households in New York City for the year 2000 is a time series data, or whether it's a time series or cross sectional? It's a false, right? Yeah, it's a cross sectional. Yeah, it's a cross sectional because what you are saying, you can see here, we are time is the same, right? For the year 2000, 2000 only, we have collected the data of gross annual income for 1,000 randomly. Okay, so let's say for year 2000 there is some thousand something like that. Okay, it's a wrong. This PNR number has a ordinal scale of measurement or not? Be wrong. Why PNR number is in digit, right? It should be some, I can order, right? It's a nominal. Okay. Well, it's Tanisha, right? I think I should see if you people will do like this, I will stop the uh, I will disable the chatting option also. But don't do this like this. Okay. So PNR number, it doesn't have the ordinal scale. First of all, PNR number is not numerical data. It will have the nominal scale of it. What about this revenue generated by India through tea exports of 10 different countries in 2010 is a cross sectional data. It's a true because we have 10 different countries. Let's say C1, C2, C3 up to C10, right? And for 2010, we have collected the data. And search size is a categorical variable, right? Because search size you cannot perform any meaningful mathematical operation. All right. So you are getting the idea, all right? So how to do these kind of questions? Yes or no? Right? So you have to be clear with some basic concepts, right? So if you are okay with this graded assignments and practice assignment and also activity question, I think that will be more than enough to do the questions. Okay, I will now move to the scales of measurement. Okay. So scales of measurement has four things: nominal, ordinal, interval, and ratio. Okay. So, and the one key thing, suppose some option is given to you, some scenario is given to you, and question is identify the scales of measurement, right? So, very first thing, what you have to observe there, just see whether data is categorical or numerical. Okay. Why? Because for categorical data, if you have categorical data, right, then this nominal and ordinal is, and for numerical data, this interval and ratio is there. So whenever, first of all, just see whether it's a categorical data or numerical data. If it's categorical data, then you have to identify whether it's nominal or ordinal. If it's numerical data, then you have to identify whether it's an interval or ratio. Okay, I will quickly go through these scales of measurement. So how will you identify whether it's a nominal or not? First of all, I told you about this is the norm for categorical data. So for nominal scale of measurement, it has only categories. Okay. And labels. And it you cannot order because it's a nominal data, right? So you cannot order. Okay. For example, suppose I'm writing gender. Okay. So gender for female and male, it will be nominal or ordinal. So it will be nominal, right? Because you cannot order, right? First of all, this is the category, right? First of all, this is categorical data. Then I can apply only nominal and ordinal scale of measurement. So you can simply see here, here I cannot do any order, right? You can't say female is greater than male or male is greater than female, something like that. All right. Let's say I'm saying blood group. Okay, so blood group will have nominal scale of measure because A positive, B positive, all these kind of things. So there is no any there is not any particular order in between the categories. All right. Okay, so you have to see whether it's categorical data or numerical data. If it's categorical data, then you have to identify whether it's nominal or ordinal. If for categorical data there is no particular order, you will go for the nominal scale of measurement. Yes, for phone number, it's a nominal scale. Now, while for the ordinal scale of measurement, so that key difference is it's a name categories with order, right? Means I can apply, there will be order in between the categories. For example, suppose I'm saying, let's say ratings, something like that. Suppose I have ratings, and ratings are, let's say, like excellent, average, and bad or poor, something like that. So here, if you see for this category, all categories, there is a order, right? I can write, excellent, then average, then bad, or I can do in reverse order also. First of all, this is the categorical data, right? If it's categorical data, you have to see whether for each categories order is there or not. If it's order is not there, it will be nominal scale of measurement. If order is there, then it will be ordinal scale of measurement. Let's say I'm taking this example, t-shirt sizes. Okay, t-shirt. So let's say small, medium, large, extra large, right? So for this ordinal scale of measurement will there, because this there is a order, right? First will be small, then medium, then large, then extra large, or something like that. Okay, is this fine? Clear? Okay. Why? Because you can order, right? There will be order for between each categories. Okay. If there is no order, you can. I mean, it's a categorical data, and there is no order. Then it will be nominal scale. Now, so we will move to the called interval scale of measurement. So for interval, I told you, right? In few minutes before, like for categorical, nominal and ordinal is there. For numerical, interval and ratio is there. So if you see there is any numerical data, then you have to go for this interval and ratio. So key thing is for interval scale of measurement, what you have to observe, basically you have to keep in mind something called absolute zero. Okay, so absolute zero property is not fulfilled here in case of interval scale of measurement. Okay, and due to this basically definition of numerical scale sorry, interval scale of measurement is all the numerical values that can be added or subtracted. Okay, so due to this absolute zero property, right, here in case of interval scale of measurement, no absolute zero is there. So due to this absolute zero property, the absence of absolute zero property will like, I mean, this absolute zero property is the key thing to differentiate between interval scale of measurement and ratio scale of measurement. Okay, so I will tell you what is the meaning of absolute zero. So whenever I will say absolute zero, so that means absence of that particular thing. Okay, means that particular thing is not available at all. Okay, for example, I will say, let's say zero phones. Okay, zero number of phone, that means there is no phone. Okay, let's say I'm saying zero number of pen in my bag, that means there is no pen. Okay, suppose I will say that is meaning of absolute zero. I'm not going then I will explain you. Suppose I'm saying zero number of cup. Okay, that means in an almirah, that means there is no cup in that almirah, something like that. So I mean the key thing is you have to observe there should be meaning of zero, right? While in case of interval scale of measurement, there is no absolute zero. So what do you mean by no absolute zero? Suppose I will say 0 degrees Celsius temperature. So does this mean there is no temperature, or there will still be some temperature? Okay, yeah, correct, there will be still some temperature, right? So your meaning of zero is not correct. There is this property, absolute zero property is not satisfying here, right? Similarly, so key thing is, so in that case we'll say interval scale of measurement, right? So key thing is okay, suppose I will say 0 degree Kelvin, then there will be temperature or there will not be any temperature? No, right? Yeah, in case of Kelvin, it's a not, there is not any temperature. Okay, so in degree on one key thing you can keep in your mind in interval scale of measurement, right? So I told you we can perform only addition or subtraction. We can do only do only addition and subtraction. So why? Because of this absolute zero property. So for example, why cannot perform multiplication division? I will tell you. Suppose this is the 0 degree, okay? And lower limit is -273, and suppose this is the 40 degree, and suppose this is the 80 degree. Suppose I'm saying the amount of temperature from this to 40 is A, and amount of temperature -273 degree to till 80 is B. Can I say B is 2 times of A? Just think and let me know. Can I say B is 2 times of A? No. All right. Because of this absolute zero property. See, here meaning of absolute zero is not fulfilled, right? It's not satisfying. And due to this, it is taking value below zero. Okay, due to this it is taking value below zero, and that's why we can perform only, and because only we can perform only addition and subtraction due because of this b is not equal to 2 times a, I can say is not equal to half of b, right? So interval scale of measurement we cannot perform multiplication and division because of this absolute zero. So what a key thing you can keep in your mind, this interval scale of measurement it can take value zero below zero also. For example, in case there will be one question in mock, I will give you the answer for this. I think there is one question related to that negative marking, right? Yes or no? Those who have seen, let me open that. Maybe that will give you the idea. Okay. So I'm not going to discuss the questions of the mock, but I will let you know the thing. Just give me a second. Here it went. Okay, I'm not able to get it right now. So think question was like whether you are able to if you are able to find, like, see, sometimes you can you may have seen for competitive during the competitive, I mean result of competitive examination and all, the marks can go in negative also, right? If minus marking are there, right? Then in that case you can say it's a interval scale of measure, right? So I'm not audible, right? Is it okay, fine. Okay, so key thing is you have to see whether it's a whether you are able to take, I mean there is meaning of zero or not. If there is this absolute zero property is not fulfilled, it will take value the zero, it will take value below the zero as well, then it will come under the interval scale of measurement, and due to this I'm able to perform only addition and subtraction as you can see here. Okay, so and like you can simply say due to this we can say there should be equal interval. Equal interval means, suppose I'm saying I have interval, let's say 30 degrees Celsius, 40 degrees Celsius, 50 degrees Celsius, 60 degrees Celsius. So the amount of temperature, like difference of temperature, let's say from 40 degrees Celsius to 30 degrees Celsius, it will be same as 60 degrees Celsius to 50 degrees Celsius. Okay, this is something you have to keep in mind, right? Okay, so like one example lecture also, suppose inside the room temperature is 20 degrees Celsius, outside is 40 degrees Celsius, then you cannot say outside temperature is twice than this. You will simply say, because this is the interval scale of measurement, you cannot perform multiplication and division. You will say the difference of temperature is 20 degrees Celsius. You can't say it's twice. All right, clear? Okay. Population growth will comes. I need to check where is this population growth question. Yeah, for this question, this is negative mark, right? So it will be interval scale of measurement. Okay. So let's come to this part, ratio scale of measurement, right? So in case of interval, what we have seen, numerical values that can be added or subtracted, right? But in case of ratio scale of measurement, so by the definition, I will say numerical values, okay, that can be added, subtracted, means I can perform all the operations, multiplication, and I can perform the division also. And there is one property, absolute zero property in case of ratio scale of measurement. Okay, so absolute zero property is fulfilled in case of ratio scale of measurement. So for example, suppose I am going to take this example. Okay, suppose this is 0, and this is, let's say, 40, this is 80, and let's say 120. Maximum can be anything. Okay, I'm not going to that. So key thing is, suppose I'm saying there is a person A, okay, who has, let's say, this number of books in his almirah, right? Suppose person A has 40 books in his almirah, and person B has 80 books in his almirah. Can I say here B has the number of books, it has twice than A? Yes or no? Can I say yes? Okay. Why? Because of this absolute zero property, right? If I will say 0 books, then this means there is no books, right, in almirah. So key thing is, due to this, if so this is the base, you can simply say, if you are going to consider this is a base means there is a meaning of this zero. It is not going to take value below zero. Then I will say B is twice than A, right? If B equal to 2 times A, I will simply say A is half than half of B. Okay, so here you can simply say I can perform the multiplication and division also. So you have to keep in mind, if you are able to perform like if you are there is a meaning of absolute zero, it will be ratio scale of measurement, and property of absolute zero is not fulfilled, then it will be interval scale of measurement. Okay, so there is a question, let me go there. Okay, this will come under the, okay, for this question, this is the question. Okay, so this is question given to you, table given to you: person, household size, region, income range, age, and purchase and all. Okay, can you tell me, for what is the case here? Person 1 or this 6 will be case? Person 1. Okay, all right. Okay, tell me, what about household size, whether it will be discrete data or continuous data? Discrete or continuous data? Who is Atharv? I think this is, my voice is clear to others, right? Yeah, household size is the discrete data, right? It can't be, household size means number of person in a room, in that house. What about region? It's a categorical data or numerical data? Categorical data. All right. What about income range? Categorical data, numerical data here? Income range. Just see the values here. Then you can, whether it's a categorical or numerical. No, those who are saying numerical, it's not a numerical here, right? Because we don't know here lower limit, right? I didn't take 40K to 50K, right? Here interval equals are not, I mean, length of intervals are not equal, right? It's a categorical data. So here it's a income range I'm talking about. You can consider this is a category 1. This is the category 2 of income. This is category 3 of interval income. Clear? Okay. Okay. So here it's not like that we have given fixed interval. It's an income range, right? And also which scale of measurement will be appropriate for this income range? Ordinal or interval? Ordinal, right? Yeah. It will be interval if I will suppose income range is 40K to 50K and last is 90K to 100K. Here it is simply written, less than 50K. So we don't know what is the lower limit, right? So it can be less than, it can be 30K from 50K. If it is from 30K 50K, then there is no I mean length of each interval will be different, right? Similarly, if I will write 90K to 150K again, then so it can be anything, right? It is not from also it is not starting from zero. We don't know, so we can consider these kind of things as a categories. Okay, I mean there were similar question in activities. You can see. What about age? Is discrete or continuous? Age, how can you say it's a discrete? Age you have to count or you have to measure. Right, age is a continuous. You are going to, don't see the values only. Just see the property, whether it's you have to count or you have to measure. So age you are going to measure in years, right? So 20. So age can I also say 23.2, right? Suppose there is a interval 23 to 30. You took a data, it can be anything, right? 23.2, that means 23 years 2 months, something like that. Okay, so age is something you it will be continuous. What about purchase? So categorical or numerical? If it's categorical, then which is scale, ordinal or nominal? Nominal. Okay, great. So now you can see answers are correct, right? So purchase and region are categorical variables. So option A is correct. Income range has a nominal scale of measure. This will not be correct because here each categories you can do the you can do, I mean, you can do the ordering of the things, right? Age has a ratio scale of measurement. Yes. If you say 0 year person has a 0 year, that means that person doesn't exist, right? Something like that. Household size is a discrete numerical variable. Yes, because household size represent the number of people in a house. Purchase has an ordinal scale of measurement. No, because purchase is just two category. Yes, no, yes, no. You cannot do the order in between, right? Okay. Yeah, 0 Kelvin is absolute zero. Okay, all right. So you can see questions are very simple from last year question paper. So thing is that you have to be clear with the very basic concepts. Okay, all right. So now I will move to the week 2 concepts. Just give me 2 minutes. I will be back. Okay, yeah, I'm back. Okay, so now as of now we have discussed, we discussed something about like data, types of data, time series data, right? Cross-sectional data, structured data. Then we saw like categorical data, numerical data. So now in week 2 mainly we are going to discuss more about categorical data, right? What else we can do or what else we can explore about your categorical data set. Okay, so now we will start the very basic thing which is called frequency distribution. So here from here onwards I will so first what I will do now, I will just quickly cover the concepts of week 2 and then I will discuss the questions of week 2 from the last year paper. Okay? So in, first called it's called frequency distribution. Okay? In frequency distribution, I mean what we have to do, we have to basically whatever the categorical data you have, you are going to make a list of distinct value and their count. Okay, what I mean by distinct value and their count? Suppose I have a categorical data, let's say female, male, female, male and female, something like that. Suppose I have this categorical data. Okay, then how will I make the frequency distribution? So what is the distinct value? Distinct value means distinct categories. So you have two categories here only, two distinct category. First one is female, another is male, and in another column you have to make the you have to basically you can say simply you have to write the frequency of that, means count of this. So for female you can simply say how many females are there, 4, and for male you have 3. So this is something called frequency table. It means what you are going to do, you are going to make a list of distinct value and their count. Okay, suppose you have three categories, let's say A, then B, then C, then C occurs 3 times. So whatever the different categories you have, you are going to make the count of in front of that category. So that will comes under the frequency distribution. Another is called relative frequency. Okay. So, but thing is that okay, by the names we are going to take the relative of that. This you can simply relative means we are going to take a proportion, or means a ratio of the frequency relative frequency. What we are going to do, will take the ratio of the frequency to the total number of observations. Okay, so total number of observations is nothing but you if you will add all the frequency, that will give you directly total number of observations. For example, from this table you can simply say, suppose I will ask what is the total number of observations. So rather than counting 1 2 3 something like that, if you will directly add this thing, you will get 7, which is n means total number of observations, which is equal to summation of all the frequencies. Okay, so here we have only two categories, so it's very simple. But if you have a large data set, then rather than counting, it's good to go with this summation of all the frequencies. So why the relative frequency? But it should be next your question. Means suppose you have frequency table, then what's the need of relative frequency? Basically, relative frequency helps us to compare the two different data set. Okay, so it's for comparing two data set. Okay, so I told you that how to you can calculate the relative frequency. So for this data set, uh, for I have gender, and this is female, this is male. So frequency is here for 4, this is 3. So what is the relative frequency? You can make the relative frequency. So relative frequency is what? A ratio of frequency to the total number of observations, right? So total number of observation is 7. So what will be relative frequency? It will be 4 divided by 7. It will be 3 divided by 7. Okay, so 4 divided by 7 and 3 divided by 7 will be how much? You can simply calculate this one. So key thing is what you have to observe here, summation of all the relative frequency. If you add this 4 by 7 and 3 by 7, it will be 1. Or if you will convert into percentage, then it will be 100%, because this here we are taking the proportion, right? Proportion of that particular frequency to the I mean basically ratio of that particular frequency to the total. What is the total frequency? All right, so you can simply interpret from here summation of, I'm writing RFI for all relative frequency, nothing but 1, and summation of, if you add all frequency, it will give you the total number of observations. So these basic things actually uh, are very helpful. These concepts will be helpful for you to during your examination. Okay, while because you can get the questions related to this. Let me see whether it is there or not. uh, it's not there, but yeah, it's a you can say it's this concept is important, because you can see the questions. Let me check from the activity. Okay, uh, Yeah. So these kind of questions, right? These you can say cause, number of deaths, relative frequency. These kind of questions you can practice. This will be helpful for your examination and all, because relative frequency, this frequency distribution, relative frequency, these topics are very important. Okay. So you can see in the question. So what is the very first question? How many deaths happened in city in 2019? So it is asking, basically it is asking about total number of death. Okay. And you can simply say for others row, okay, you have been given this frequency, and you have given this relative frequency, and by the formula you know what is the relative frequency for any category. So relative frequency is nothing but frequency divided by total number of observation. If I need total, then I can see here total will be how much, frequency divided by relative frequency for ith. So for for this last row, you can see what is the frequency, 300, and relative frequency is 0.3. If you will solve this, you will get the 1000. Okay. So you got the total number of observations. Okay. Now if I will ask what is the value of t. So first what you have to check what is the t is nothing but it is asking relative frequency for cancer, right? I mean cancer. So what is the frequency for this? So frequency is nothing but I'm writing fc for cancer is 150. So what will be t? T is nothing but relative frequency for this. So 150 divided by 1000. So it will be nothing but 0.5. So you can simply do this, right? So what you do, this is very basic formula which you have to keep in your mind. Okay. All right. This is clear to all of you, right? This relative frequency and all. Okay. All right. Fine. Okay. Then now we will move to the part, like how you can visualize, okay, this categorical data. So there is something called bar chart, okay, and pie chart, okay, and Pareto chart. So I mean there are different, I mean we can use these kind of charts in different scenario. So we have to, means our task is to identify those scenario, okay, in which scenario I can use bar chart, in which scenario I should use pie chart, in which scenario I should Pareto chart, something like that. Okay. So bar chart is nothing but, okay, so see, you have seen the frequency distribution. So for frequency distribution we are interested only in count of each categories, right? uh okay, I think if you do like these things, right, though I think I it's not a good thing, right? Okay, so I'm going to disable the chat also, right? I think you are guys are not ready to understand this. Okay, all right. So sorry for that, but I had to do. Okay, because some people were disturbing there also. It's you should maintain the no standard of the class. Anyway, we are taking the revision sessions for you. Okay, it's not for us. So you should keep focus on the concept rather than doing some nonsense thing. Okay. Okay, so let me give the this explain the bar chart kind of things. Okay, so bar chart, I have given the idea about this, right? Frequency distribution and relative frequency and all. So in frequency distribution, what we are saying, we are interested only, count of the things. Okay, so bar chart is helpful when we are interested only in count. Okay, so if I want to show the count of categories, okay, then I will use a bar chart. What do I mean by count of categories? So in the previous example, so you can simply see I had two categories, right? So first one is female, second one is for male, right? So here on the y-axis, I will simply show the count. So it will, let's say 0, this is 1, this is 2, this is 3, and this is 4. So for female, there were 4 female. For male, there were 3 male. Sir, what we are doing basically, we are just like I'm just making a bar for each category, and here you can see for this bar, this is representing the count of this for female category, and this will represent the count for the male category. So bar chart is helpful whenever you are interested in only the count of categories. Okay, let's say I have 3 categories, A, B, and C, something data set, and I have, let's say for A, let's say this is 5, this is 10, this is, let's say 15, this is 20. Okay, so for A, let's say this is 10. For category B, suppose it is 15. Okay, for category C, suppose this is the 5. So what is the case here? Here I'm interested only in count of these categories. Okay, so whenever you are interested only count of categories, you have to make a bar chart. So here you can say this data is nominal, right? I mean, if you will make the bar for male first and for female later, that doesn't I mean create any problem or something like that. But if you have ordinal data, okay, suppose you have ordinal data, let's say t-shirt sizes, okay. So since I heard ordinal data, then order must we have to order must preserve, means we have to keep uh, maintain, we have to basically maintain the order of the categories, because that's the meaning of ordinal data. If you have ordered ordinal data, then you have to maintain the order of the category. So suppose you have data set of let's say small t-shirt size, medium, and large, then you will make the bar for small first, then medium, then large. You can do in reverse order also. Let's say you can do for large, then medium, then small, but key thing is there, you have to maintain the order of the ordinal data set, right? It can be anything, right? It can be something like this or something like this, something. I mean, it's not about numbers, it's about order of this category. It can be like this. Suppose your data set of small something, and medium is this, large is, let's say, this something. So it's not about numbers, it's about order of these categories. Okay, it can be this can be different scenario, this can be different scenario. So what is the key thing? You have to preserve the order of the your ordinal data set. Okay, so bar chart is basically when I'm interested in only count of each categories. Okay, so what about Pareto chart? Okay, so Pareto chart is nothing but when I'm interested to know, basically Pareto chart when is nothing but when I'm going to sort the frequency, right? Means it's nothing but when categories, right? When categories, whatever the categories you have, A, B, F, female and male, in a bar chart, okay, are sorted by frequency. Okay, so sorted by frequency means, suppose for this case, okay, suppose you okay, it's already sorted in descending order, and here ascending order, sorted by frequency. Suppose this is 10, this is 15, this is 5. Okay, so what will be the Pareto chart? Suppose for C, this is 0, this is 5, suppose this is 10, this is 15, and this is, and suppose then what is next is 10 A, then this is B, this is 5, this is 10, and this is 15. Okay, so now this you can say this called the Pareto chart. So why in Pareto chart what we are doing, we are going to like we are going to order the frequency, right? Either in ascending order or descending order. I mean, normally if you see on Google or anywhere else, you'll normally find Pareto chart in descending order, but anything is correct. I mean, basic key idea is we have to sort the frequency. That's all. So you can do it reverse order also. It can be B first, then A first, then C first. It will basically depend on your objective. Means suppose you wanted to by your intention or something like that, you wanted to show maximum number of like maximum sales of product B or in last month or something like that. uh, like yeah, sorry, suppose there is a shop or a big store, and there are three items: item A, item B, item C, and item A. And you wanted to show for B, I mean, this item has been purchased, maximum purchased by maximum people, then item A, then item C. And you can do in reverse order also. Okay, so thing is that we have to basically sort the frequency. While if you have ordinal data, then it doesn't matter whether you are going to sort the frequency or not. But what the key thing is, you have to maintain the order of that data set. Okay, that is the importance of your ordinal data set. Okay, so this bar chart and Pareto chart is something like that. But what about pie chart? I mean, in which scenario I will go for pie chart? So pie chart is nothing but when I'm interested, I'm trying to compare parts of a whole. Okay, parts of a whole means suppose I have something I have in 100%. Okay, then I want to compare a particular parts. Okay, for example, one case you can take here, like number of votes received by candidate A, candidate B, and candidate C. Okay, then if I'm interested in only number of votes, suppose candidate A received 10 votes, candidate B received 15 votes, and candidate C receives 5 votes. Okay, so this will for this you will make a bar chart. But for pie chart, suppose I'm interested in percentage of votes, okay, received by each candidate. Okay, then in this scenario I will prefer the pie chart. This suppose, so pie chart is nothing but this circle. So you say, yeah, let's say some percentage. You can convert then these things in percentage. Suppose X% votes received by candidate A, and Y% votes received by candidate B, and Z% votes received by candidate C. Something what you are going to do here. Basically, pie chart is useful when I'm trying to compare the parts of a whole. Right here, you want to compare like how much percent votes received by candidate B, how much percentage of votes has been received by candidate C. All right. So these kind of scenario, while in bar chart, I was interested only in count, not in this percentage things. Okay. So you can say pie chart when to use when you are trying to, let me write, compare parts of a whole. Okay. Suppose another scenario I can take. Suppose I'm a owner of a company, then I so, and in that company, let's say we are manufacturing uh, some 3 to 4 items. Okay, so at the end of the year, I would be interested to know what is the sales distribution. Suppose there is some sales, let's say 100% sales distribution. Okay, not every items. I mean, let's say at the end of the year there will be some sales distribution. I would be interested to know what is the sales distribution of item A, item B, similarly for product C and product D, something like. So it can be any number. It can be X percentage, Y percentage, Z%, and let's say M%. So key thing is what you have to observe here. All the, if I will add X% plus Y% plus Z% plus M%, it should be equal to 100%. Okay, these things you have to keep in your mind. If this is not come, if you are going to add all this percentage, then it is not coming up to 100%. That called round off error. Okay. I mean, what do you mean by round off error? Suppose you have rounded off some value for your simplicity. You want to avoid some decimal points, and for your simplicity and all, then you rounded off the values, and by mistake you have done some. You rounded off the value, and if you are going to add all the value, you are getting 101%, right? So this is not a this is something called round off error. Okay, in pie chart space. Okay, so there is something in each case called area violation. Okay, we have to keep those things in mind. So what do you mean by area violation and all? Basically some, okay, in this area violations, first is called, you can say, area principle. Okay. Okay, I will let you know what is this area, meaning of this area principle. So the meaning of this area principle means like the area occupied by the part of the graph, okay, should correspond to the amount of the data. Okay, means area occupied by, a part of the graph. I will draw the graph and I will explain you the meaning of this. That area occupied by a part of the graph should correspond to the amount of data, amount of data it represents. So what is the meaning of this? For example, I'm going to draw a pie chart. Okay, suppose this is the pie chart, and suppose this is area, and like that. So suppose this is something 50%, and suppose I have written this is a uh, let's say 15%, and this is the 25%. Okay, or this is the 35%, not only this would be added to 100. Now you can see here this area. Okay, this the thing which I'm highlighting with red. So this is written as 35%, but the area, what you can say, area occupied by part of the graph should correspond to the amount of data, right? But this, you can say, this is not, seems 35%, while if you see this, green one, this is only 15%, but this should be something 35%, right? So this is something called area principle. Okay, we have to keep in mind, our mind. Or else suppose I have written, okay, let me write like this. Suppose I wrote like this. Suppose this as a 50%, and this one as a, no, some 15%. So here this is this area principle, this concept of area principle is violating, right? So the area occupied by the graph, so this you can say, this part doesn't seem 15%, right? So it should correspond to the amount of data it represents. Okay, I'm hoping this is clear to all of you. Okay, while in the bar chart, something we have to keep in our mind, it should start from the zero also, right? If it will not start from the zero, that is called the missing baseline. Suppose you had drawn the bar chart something like that. Let's say 5 A B C, and let's say 10 15 or something like that. So this is 10. Okay, so this is here, it is not starting from 0. So this is called something missing baseline. Okay, in bar chart. So key thing is, we have to, these kind of, this is called a truncated graph also. These kind of things we have to keep in mind. In bar chart also, something called, manipulated y-axis. Okay, so what is the manipulated y-axis? Basically, if we, okay, there is no need, and you have, for your your intuition, what you have done, you have simply uh, extended the y-axis, or okay, let me give this. I think I took this example again and again, but I will explain. So you can see this from here. So what is the manipulated y-axis? Basically, suppose you have no, but without any I mean, like without any need, you have just basically expanded or compressed the y scale on the graph. Okay, then it basically what it does, it makes like change. I mean, it seems there is a change in data. For example, if you see this graph, and there is two kind of a smartphone A and smartphone B. So at the very first, glance, it feels there is a significant amount of number of cells of smartphone A and a significant number of cells of a smartphone B, right? But if you have expanded the y-axis till 300, but it was not needed. See, even though data is correct, but at the very first thing I will see this graph, it will it seems like for both smartphones there is less I mean less number of phones. I mean smartphone A and smartphone has been sold out. Okay, so key thing is I mean you have manipulated your y-axis. Okay, these kind of things comes under the you can say manipulation y-axis, manipulated y-axis. So basically you have you expanded or you have compressed the scale on a graph. Okay, so these kind of things comes under the uh, manipulative y-axis. So one thing I will explain something called measures of central tendency. Okay, like what I mean by it's called mode and median. Okay, so mode is something which this is the which occurs more frequently. Okay, and median divides the data into two equal parts. Okay, now as of now we will focus only for categorical data. We are not moving for the numerical data. So for example, suppose I have a data set, let's say B, A, C and C. So what will be mode here? So you can say mode will be A because A occurs maximum number of times. Okay. For example, you have another B. So then you can see here A is occurring 3 times, B is also occurring 3 times. So here mode will be A and B, and this data set will call the bimodal data set. Okay. Means if you have single mode, this is unimodal. If you have two mode for that data set, you will say this is the bimodal. If you have more than two mode, you will say it's a multi-modal data set. Okay, so this is data set something which suppose that generally I'm not able to order, but suppose I have data set something like that. Let's say t-shirt size small, medium, small, large. Okay, in this case what will be the mode? Mode will be S because S occurs 3 times while L occurs 2 times, M occurs only once. Okay, but what about median? If you see median, so median is what? Let's say again S, for example. Okay, so median is which divides the data in two equal parts. So median is something, to calculate the median we need to arrange the data. Okay, but in categorical data, as of now we are focusing only categorical data. So for categorical data there is only two things, right? Whether it will be nominal or it will be ordinal, and we know there is no order for nominal data set. Okay, we can order only for ordinal data set. For example, for this category we cannot find median because there is no particular order. I mean, suppose this is simply alphabets A, B and C, then you can't order, right? While you can see this one, I can order, right? I can write S. Okay, this t-shirt sizes, then M, then L, then. So median is what? Which divides the data into two equal parts. So this we have 7. So we can ignore this first 3 and last 3. We will be having S. So here median will be S only, correct? All right. So median is defined only for ordinal data. Okay, we cannot calculate median for nominal data. While mode, you can see I was able to calculate the mode for this data and for this data also. So mode is defined for nominal data as well as ordinal data. Okay, because see, mod is what it will give you just the category which occurs more frequently, more number of times, while for median we need to arrange the data. Okay, one more thing, you to see mod is what which occurs more frequently, right? So more frequently I can if you see the bar graph, so which has the high no longest bar, that will give you the mod of that data set. So for this mod will be B. Okay, so category B, not 15. B will be mod. Okay, so you can simply say B occurs maximum time. So this means B has occurred 15 times, A has occurred 10 times, C has occurred 5 times. While in this case, what will be the mode? Mode will be female, right? Okay, suppose I am creating a scenario. Suppose I have scenario like this. Okay, suppose this is A, this is B, and suppose this is C. Okay, and suppose this is 15, this is 15, starting from 0. So what will be mode? It's a mode will be A and C, because both have the same frequency, and which has the A is also occurring maximum number of times, right? 15, and C is also occurring maximum number of times. Okay, so in case of this and bar chart, longest bar will represent the mode. Okay, while in the Pareto chart, you can simply say, yeah, this is the longest one, this is the longest, it will give you the more. But for pie chart, the widest slice, right? So suppose this is the 50%, and let's say this is the, let's make it correct. Suppose this is 35, this is 15. So this 50%, let's say this is for product A, this is for product B, this is for product C, for example. Then, so product A will be mode here. Okay, because mode is what which is occurs more frequently. Since in pie chart we are dealing with the percentage, or we are dealing with the proportion thing, so that's why widest slice, it is giving, because it's we are talking about in terms of area, right? In not in terms of count. So widest slice will give you the mode of that data set. So what you have to keep in your mind, median is defined only for ordinal data. If you have been given any nominal data, and question is calculate the or find the median of that nominal data set, and in the option if there is something, then you have to choose that option, whether so key thing is you have to observe median is not defined for nominal data set. Okay, so if it's nominal data set, then you will simply say, yeah, we cannot find the median of this data set. If it's ordinal data set, then you have to think, first of all you have to arrange in ascending order, then you have to find that middle observation which is going to divide the data set into two equal parts. Okay, so I'm going to no, give me a second. I'm going to okay, so I'm going to share my screen, and with the question paper which we have discussed in okay, in the which we got in the last term. I mean, it was from the last year paper, question paper. Okay, this is from week 4. We are not going to discuss that one. Okay, so thing is, okay, just give me a minute. Okay, fine. Yeah, I'm back. Yeah. So sorry. Okay. So as we have discussed the content and all. So I will say I'm going to share my screen and we will discuss the questions which came in last term last qualifier paper. Okay, so let me share my screen. Am I audible to all of you, right? Yeah. Okay, fine. So let me share my screen. Okay. So first of all, read this question. Okay. Question says, an analyst conducted a survey to understand the opinion of college students regarding the quality of education at their institution. He collected the data from 10 students as this like this. What is the mode of the this given data set? Which occur most frequently? Okay, in case of someone is poor, yeah, poor occurs maximum number of times, right? Let's say 1, 2, 3. If you have someone is asking if in case of even number of objects, suppose you have even number, let's say one more L, right? So then what will be? It will be S. Let's say S M. How many L? 3. Okay. So 1, 2, 3. Suppose I 3. So it's 3, 3, 6, 1, 7. So 4S. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So you can ignore these three. I mean, so medium will be this as this small size and medium size, right? So it will be either S or M. Okay. You can't take average of these two because in case of numerical data, I can take average, but in case of categorical data, it will be either S or M. Whatever the option will be there, you can collect, you can choose these things. Okay. You can't define exactly, but it will be either S or either M. Okay. So based on this question, tell me what is the median of this. First of all, median is defined or not? Give me the answer for that. Median is defined or not? Median is defined, right? No, it's defined, right? So here I can order, right? So I can order poor, then I can write fair, then I can write the excellent, right? So it's the ordinal data set. I can find the median. If it's ordinal data, what is the median of this data set? Just order and take a minute and let me know. Concept should be clear. It shouldn't be like you saw the answer. I can show you the answer B. Fair is the median, but you should be know how. Okay. So no, for qualifier exam, concept will be till week 4. So first of all, you have to arrange. So it will be poor. Okay. Poor, poor. Then how many times? Sorry, poor is time 4 times, right? Yeah, 4, and fair is 1, 2, 3. So fair, 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 excellent, 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 okay. Excellent, excellent, and excellent. So you can see how many. So it's 4, 3, 7 is 10, right? So if you see, if I will ignore the 4 of here and 1, 2, 3, 4 of I mean this is the even number, right? So fair will be median, right? So you can simply see fair is the median. So fair is the correct option. Is this clear? You are getting the idea, right? Correct? Yeah. Okay, fine. So general doubts and some uh, ops related out, you can talk to the support team. So this is question from week 4. Since we are discussing with this part only. Okay. So okay, what about this? See, which option should be correct? See, anyway, I so it's already answer is visible, but you have to clearly see. Two data set with identical frequency distribution will have identical relative frequency distribution, right? Correct. Identical frequency distribution means you have the same frequencies, right? I have data set, let's say 10, 20, 30, A, B, and C. It will have a relative frequency. Then another data set I have, let's say F, G, H, then again 10, 20, 30. So this is identical frequencies, right? Then relative frequency will be identical. What about a relative frequency is the number of observations belonging to category? This is true or not? No, right? So relative frequency is ratio of the frequency to the total, right? It's not number of observations. So frequency is the number of observations belonging to category. What about two data set with identical relative frequency distribution? Will always have identical frequency distribution? No, right? Why? Because suppose I have two data set, let's say this 10, 20, 30, A, B, C, and it will be having same relative frequency. And suppose FGH and uh, okay, relative frequency will be what here in this case 10, 20, 30. Anyone can tell me 10, 20, 30. So it will be basically 10 divided by like 30, 20, 50, 60, right? So 1 divided by 6, right? Okay, so I'm writing 1 divided by 6, then 2 divided by 6 and 3 divided by 6. Okay. Suppose this is again 1 by 6, 2 by 6, 3 by 6. Here relative frequency are same, but it can be 100, 200 and 300. So in both cases, you will see relative frequency are same, but frequency distribution are different. What about if all the bars in a bar chart have the same length, then the categorical variable shown in the bar chart has no variation? Is this true or not? See, don't see the answer. Just tell me the reason. Can you tell me the reason why it's not true? Why it's wrong? It's talking about variation. Frequency is same or yeah, basically all the bars have the same length. So okay, let's say 10, 10, 10 for example. Okay, so no variation means it is talking about variance, and we cannot calculate the variance in case of numerical categorical data, because for categorical data you need to take care of the meaningful mathematical operation. Okay, so these were okay. One more question is there you have to keep in mind. So suppose here question is these all things is given to you. Okay, let's just read the question. So this figure Q.2 it illustrates the proportional distribution of renewable energy as consumption across various sources throughout the country. So total renewable energy consumption is given to us 350. Okay, so for solar, wind, hydro, biomass, geothermal is given to you. So question is, first of all, find the value of 10 times of x. So what is the case? How will you find the value of x? First of all, we know summation of all the pi should be equal to 100%, right? So I should write x plus 10.7 plus 7.1 plus 17.9 plus 28.6 equal to should be 100%, right? From where I can calculate the value of x, so it will be 100 minus addition of all these things, right? So if you will calculate, so 100 minus, let me add these things, it will be 10.7 plus 7.1 plus 17.9 plus 28.6, which is 64.3. So which is 64.3. So if you will subtract from 100, you will get 35.7. So for x, this is the 35.7%. And I mean, x is 35.7. So this will be 35.7%. So key thing is what we have to observe, summation of all the slices of pi it should be equal to 100%. Okay. So question is about 10x. So x is 35.7. Then 10x will be 357. Is this clear? Right? Yeah. Okay. And you have to choose the correct options. So what is the mode of the, it is saying mode of the data is solar energy. Is this correct? Mode of the data set is solar energy. Yes or no? If yes, then why? What mode represents? Correct. So mode represents the widest slice in a pie chart. Okay. And here, what is the widest slice? This solar, right? And median of the data is wind energy. Is this true or not? First of all, can I calculate the median? No, right? Why? Because this is not a ordinal data, right? This is a nominal data. Correct. Yes, you have to keep in mind. So some option might be there which you will confuse. Okay. And question is the next is the combined consumption of the hydro, biomass, and geothermal energy is more than wind. So it is asking about hydro, biomass, and geothermal. So it is asking about combined this plus biomass plus these things. Geothermal it is asking it is more than no, not this is geothermal. Sorry. So geothermal is this one. It is asking about addition of these three. It is asking about it is more than this 28.6. So you have to check whether addition of these three. You can simply say 17 plus 10, 27 and 27. See, it is more than this. It's a true. Consumption of solar energy. So this 120 consumption of solar energy. Is this true? Why B is not correct? What is the B? So median of the data is wind energy. Can you calculate the median in this case? Sujan, can you calculate the median? How? For median, what is the first things? We have to, data should be ordinal. You cannot order, right? No, it's not about numbers. It's about, see, this represents the solar. This red represents the category of for wind. This represents the category of hydro, right? For hydro, it is 17.9%. You are not, I'm not talking about numbers. Okay. So this is not a ordinal data. This is not a ordinal data. This is the nominal data. You cannot order the categories. You cannot say solar is less than wind or wind is greater than hydro or something like that. This is the nominal data set. Okay. If I have nominal data set, I cannot calculate the median of data set, right? So it should be clear to you. Okay. Yeah, this is something we have discussed. So the key thing is you have to uh, take care of these minor things. Yeah, one more thing I forgot to mention, this part, right? So for this case, this for consumption of solar energy is 120 it is asking about. So for solar energy, what is the percentage? 35.7%. It is asking about, it is 120. How will you calculate? So 35. So you have to what is the total? Total is 350, correct? So you have to calculate what is the amount of this. So you will simply do 350 into 35.7. Basically, you have to take the divide by 100. So you have to do 35.7% of 350. So you will do 35.7 divided by 100 into 350, or you can simply 35.7 will be 0.357, and then you will calculate this. Basically, you will calculate this part. Okay, 35.7 into 300. Sorry, not 300, 350. Okay, basically you will do 35.7% of 350. This means 35.7 into 350. Since it's in percentage, I will divide by 100. Then I will get 124.95. So basically, but in the question, it is saying it's a 120, which is incorrect. So A and C will be correct. Okay. So I'm hoping this is clear to all of you. Okay. Okay, so I think there is a math session is also started, right? If I'm not wrong. Okay. Okay, so I will, if you are okay with that, I will take some things from you. So Asad, you have raised hand. Can you please?
Sir, how can you calculate relative frequency, sir?
For
2.1.
so relative frequency is something you have to divide the frequency divided by
No,
total
sir,
number
so
of.
in activity 2.1, they have given both also X and Y and to calculate. Can you go to that 2.1?
2.1, right?
Yes, sir.
Which question?
So 1 minute.
What is the value of x plus y, right? You are talking about. Okay, so what do you mean by x plus y there? What x represents there? X represents here frequency, right? So first calculate the x value of frequency.
The next question, sir, I think. Next question.
This x plus y.
Next.
This one.
No, next here box will come. Yeah, that one. How to calculate x and y?
Okay, tell me what this frequency represent first of all?
Total number.
Total number? No, this represents the frequency for each
Number.
things, right? So
Yes, yes.
if you want to calculate total, then how will you calculate total?
So we have to sum all these plus x. So
No,
x
forget
equal-
about x. If I will ask, see, we don't know about total, right? To calculate the value of x, I need the total, right? But if you see clearly for Sunday, I have frequency, I have relative
We
frequency.
would calculate that 0.125 is 15. So what one would be?
One second, let me speak. What I'm saying, for the first category, right? So you have 15, you have relative frequency, right? Yes or no? So what relative frequency represents? Relative frequency for ith category is frequency divided by total, right? If I want total, I will say frequency divided by relative frequency. So for Sunday, it's 15. I think relative frequency is how much? 0.125. Right?
0.125.
If you will solve this, what you will get?
120.
Right. Now you have total as 120. To calculate the you can calculate the value of x. Correct. How? Summation of all this should be equal to 120, means 15 plus 20 plus 15 plus x plus 19 plus 20 plus 11 will be 120, and you can calculate the value of x. Once you will be having you will get the value of x, you can simply calculate the value of y. What is the y? Whatever the value of x will be there, x value of that value divided by 120. Clear?
Yes, sir. Thank you.
Yeah. So
Sir,
this
actually,
Hello, sir.
I have one doubt regarding Pareto chart.
yes.
Sir, in notes 2.5, they have written at mode Pareto chart will be the if you find the mode of a Pareto chart, then there's written that first category will be the mode of the mode
Okay,
in Pareto chart.
okay, Pushparaj, if you will make a Pareto chart and you have arranged the data set in, I think there's some background noise. I think that's why I think Srijan, could you please mute yourself? Yeah, thank you. So if you arrange your data set in descending order, right? Then first bar will represent the mode. If you arrange your data set in ascending order, then last bar will represent the mode. Okay.
Sir, I have a question.
Sir,
basic thing is you have to see which has the longest bar. That's okay.
Yes, but when I go and
Can you
search on
repeat, please?
See, Pushparaj, if you have listened me carefully, I told you, normally if you search on Google and anywhere else, normally Pareto chart, they give in the descending order, right? But you can order in either ways, not a problem. Okay?
Hello,
Sir, I have a
sir.
question. Hello.
Sir, I have only one doubt. मैं चला जाऊंगा ऐसे.
Okay.
सर मेरे को ऑर्डिनल डेटा सेट और नॉमिनल बहुत दिक्कत होती है. सर आप बोल रहे थे ना उस क्वेश्चन के अंदर कि ऑर्डिनल ऐसे पाई चार्ट वाला में हमको ये समझ में नहीं आ रहा था कि ऑर्डिनल और नॉमिनल का आप बात समझ गए, बट इससे बहुत दिक्कत होता है हमको समझने में कौन सा ऑर्डिनल कौन सा.
Key thing is you have to keep in mind whether you are able to there is any order in your category or not, right? So for example, let's say okay, suppose there is a example of ratings, feedback, let's say excellent, poor, bad. So you can do order, right? There is some order, right? First poor will be there, then average will be there, only then excellent will be there, right? You can't say excellent it can be some random, right? There is order, right? You failed very bad, then you gave poor. You failed okay, then you gave rating. You are very satisfied with the food, you gave rating as excellent.
Like where we can compare things, right?
Okay, so if there is some ordering, some comparable thing, then you can that will come under the ordinal data set. Okay.
Sir, in
Thank
a
you, sir.
data set, sir,
Thank you,
how
sir.
many cases can
Okay,
be
so
there?
if you which PDF, question paper or
this one, the PY, just know what you, the January 24.
okay,
Will you share it?
Okay, I will share in that chat box. Just give me a
Okay,
second.
please.
Sir, I have
Sir,
a
if
doubt.
they ask for next highest digit for 2-digit accuracy for 0.423 means how to
Sorry?
write, sir? 0.42?
Yeah, you tell me what should be the next digit. This is very simple thing. I don't think I should explain. What should
For 3, there will be no, sir. Then 0.42 it will be a.
no. If what you are saying 0.423, right?
0.423.
Yeah. If
What is the next
0.23 is there, then what should be the answer? After 0.23, what will be the next? It's a very basic thing. I don't.
0.42?
No, next integer is asking about integer. If you will write 0.42, it's not an integer, right? After 0.423, what will be the next integer?
1.
That's all. If I will write 0.9837, I ask
Then
what.
2 decimal accuracy they are asking?
Then yeah, then 0.42. If it is asking about 2 decimal accuracy, then it's 0.42.
Sir, I have
Okay.
a question.
Oh.
Okay.
Hello,
Yeah.
sir.
Yes.
Sir, but they
I
are
have a,
given in the graded assignment range. Is that possible to write in exam?
Yeah, it will be clearly mentioned whether to enter the answer in range or integer. Okay.
Okay.
sir.
Yes. Yes.
Sir, yeah. So I was asking, am I audible?
Mm-hmm.
Sir, in a data set, sir, how many cases can be there? Like, for example, as you said,
It
roll.
depends on the data set. Suppose you collected a data set of 1,000 students, 1,000 cases.
No, sir. Like, I'm talking about like different cases. Like, roll number is only will be the case, right?
Variable.
See,
No.
roll number is a variable. If you talk about roll number, that will be under. If I will say roll number 2, that will be
Yes, sir.
case. Okay, case is this. See,
No, sir. Like, I am assuming that case is a thing, sir, which I can distinguish. Like, this case is I'm doing the, searching for things like what the roll number 2 has this and that and that. So the roll number 2 is the main thing I have to focus. So that will be there only, or there will be something else as well.
That's why, Saad, I'm saying it depends on the data. It's not about only roll number 2 or roll number 3 also, right? See, thing is this, suppose roll number is not there and you have a data set of with unique names.
Yes,
Okay.
sir. Yes, sir.
Then your all the unique name will be
Sir, for example, sir, we have like student with similar names sometimes, and we have roll number as well.
then there will be something which should be unique.
So,
It
sir,
can be roll
we
number.
have to just find the uniqueness in the data.
Correct. And
Okay,
you
sir.
have to keep in mind, first of all, unique and whether that data has been collected for that unit or not. Okay, it shouldn't be like sometimes suppose something is unique, but your data is not collected for that thing. Then it's not a case. Means it's a unit, that is a unit for which your data has been collected. Okay.
Okay, sir. Thank you.
Yeah.
Sir, what is
Good evening, sir.
approximate average?
Average of what?
I have
the doubt.
Approximate mean.
Approximate mean is something. Suppose your content that will cover under the week 3, week 4 revisions, but I will let you know. So,
Sir.
like suppose you have continuous data, right? Grouped data. Okay.
Okay, then what doubt means I have the doubt is theme and leaf. It's a number.
Okay, I think I told to everyone, right? Just speak one by one. Yeah. So approximate means if you have interval, right? Then you are taking the midpoint. Okay. You don't have exact observation. So in this case, you will get the approximate mean, not exact. Okay.
Okay. And why cannot we inference from population?
Okay. Then for what you will inference?
For anything means average.
No, like no. You are not inferring. Then you are just exploring that data. Okay. Suppose you have information about throughout the all over the India. Then to whom you are going to make for whom you are going to make the conclusion? Nothing, right?
Then we can assume like if
For
50%.
whom? Tell me, for whom? Suppose you went. Suppose you went in a room. Okay, in room there are, let's say, 50 people. Okay, and you took data from all 50 people. Okay, suppose that is the only word. You have that much people.
Yes,
only.
yes.
Then to whom you are going to make proposal? For whom?
No,
Nothing,
we could
right?
make conclusions like if 20% people like something, then we should do that thing.
No. Then you are just describing that data. Out of 50, you are saying 20% people liking, let's say, soft drinks. then you are just describe that data set. You are not making conclusion. Making conclusion
But
means you
then,
have small
if I say, then if I say that if I sell cold drink, then I will be in profit. Then we are inferencing from that data, right?
if you are saying 20% people are liking in soft drinks or cold drinks, and then you are making, yeah, in that society 20% people likes cold drinks, then it will be inferential. Based on a small data set, you are making conclusion for large data set, then it's only then it will be inferential. All right.
Okay, thank you. I got it.
Okay,
Sir,
fine.
I have a doubt from the weekly mock named week 1 and week 2, in which the
Okay.
question 5 there is a choose the incorrect option, in which
Okay.
statement is there population growth has an interval scale of measurement, and it is treated as a correct statement. So the population growth is interval scale or ratio scale
You
when
tell
it is
me.
given in percentage?
You tell me what should be correct.
I think it should be ratio. We can zero population growth means there is an absence of population growth, and
Correct.
we
So question is about incorrect option, right?
yeah,
No.
yes.
Okay, one second. Let me see the question. I think, okay.
Yes, sir.
What in case of interval, tell me, in case of interval, I told you if absolute zero property is not fulfilled, it will take value below 0.
Yes, sir.
Correct. If you see the question for, I think, Jaipur, what is the population growth? It went in negative.
Yes, sir.
Is
Sir,
it possible in case of ratio?
sir, but in that
Okay,
case,
tell
if
me,
we
first of
require
all.
something,
Okay,
area could be determined as negative, na, sir? It's all case dependent then.
Sorry?
I mean, sir, if
okay, first of all, if it's ratio, right, it can't take value below 0. That's all. Okay,
okay,
it is possible only in case of interval. Okay.
Okay, thank you, sir.
Yeah.
Hello, sir.
Yes.
Where I should use pie chart or bar chart?
Okay, pie chart is something when you want to compare parts of whole and you have something in percentage, and let's say I told you, right, if you are interested in, let's say, percentage of votes received by candidate A, percentage of votes received by candidate B, or something like that, then you will go for the pie chart. If I'm interested only in count of something, then you will go for the bar chart. Okay, let's say number of votes received by candidate A, number of votes received by candidate B, number of votes received by candidate C. Okay.
Okay, sir. Thank you.
Sir,
Sir,
can you please
these are the
explain those
only
formulas of
sir,
relative frequency and
the thing which you
frequency?
sir.
So
The thing,
relative frequency is nothing but it's a frequency divided by total number of observations. That's all. You can simply manipulate which, if two quantities is known to us and unknown, which one is third one is unknown. Accordingly, you can make. Okay.
sir.
No,
Hello.
Yes.
sir, I needed that formula we have used for that problem. That is RFI equal to
Fi divided by n. So I represent the for a particular category. Okay. Let's say for category 1. So RF1 divided by F equal to F1 divided by n. That's all. So key thing is relative frequency, nothing but frequency divided by total. That's all.
Sir,
Okay?
you said
Sir,
that
sir, when
about
the table
pie
has
charts
different
and
names,
Pareto and bar graph, sir. So, sir, these are the only way we can define that's the best uses of these graphs. Or like, you said the whole of a part. If, sir, will there be no other thing we can mention in that, thing?
No, I didn't get your question.
No, I mean, you said, sir, pie chart is best used for like when we have to. So, is there anything else in it? Or
No.
there's
This is something this is the key thing which you can differentiate.
Okay, sir.
Excuse me,
sir.
sir. Hello.
Yes.
Sir, sir, in a table there were different names, sir. So you said each name is a case. So
Yeah,
what
but in
we
that case, name should be unique.
no, sir, if there are names are different, and that means each name is a case, right, sir?
Yes.
That means on the table at the top, it will be given as name under it. All the names will be under the category of names, right, sir?
Yes.
Then what do we call that name, sir?
Name is the variable. See, that name is the variable because column represents the variable. Okay. So because under the name, you can say different names, right? So under the name, things are varying, correct? But
Yes, sir.
if you talk about, let's say, Suman, then Suman will be a case, because for Suman, you have collected your data set, right? You have collected in which class she is, what is her contact number, where is she from, something like that. Okay.
And is
So
phone number of
Okay.
Suman case?
Yes, sir.
no, phone
It's a
number is
variable.
not a case. See, if you will see, I will ask you, for phone number you have collected the data, for that people you have collected the phone number.
People.
That's all, right? So I told you, right? So whenever I'm explaining, I told you three things, right? Row represent the cases, case is a unit for which your data has been collected, and it should be unique. So you have to keep in mind these three conditions.
And if growth rate is -5 and one is other is +5, then can't we say that +5 is twice the -5 one?
How will you say? Just make a line and tell me. Can you say? Is
Why
it
not?
twice? Suppose you I scored in a exam -10, I scored 10. Okay, then
Yeah.
can you will I say I have scored twice than you?
Can't we, sir?
Can we? So tell me, give me the answer.
I have not doubt.
I mean, if we take the difference between those two and divide it, yes, I'm twice, means the other one is twice.
How you can take?
Yeah,
Just think,
taking the
right?
difference and dividing.
Okay, how will you divide? That's the question.
We are
Okay,
dividing
just
the
think.
difference.
Haridas, just see that one, -273 one and 0° one. Okay, that will give you the answer.
No, yeah, I got that one, but what about this one?
Okay, if you are saying, will you able to do? I think you are not trying to think a little. See, if I'm saying, suppose this is the 0. For example, 0 is the lower limit. Okay, this is suppose 50. Okay, this is 20. Suppose I scored, let's say I scored 25 marks. Okay, you scored 50 marks. Okay, if 0 is the lower limit, then I will say you have scored twice than me. Yes or no?
Yes.
Correct. If it is the lower limit, let's say -10 is there, 0 is there, let's say 10 is there, 20 is there. Okay, suppose I'm saying you have scored 10. Okay, and let's say I have scored 10 and you have scored 20. Just think, can you say H is equal to 2 times P?
I think yes. Means why can't we say that?
How can you say this?
Means I'm thinking like dividing the difference by 2.
Why?
Sir,
Because that
hypothetically.
gives me twice the amount.
No, you are converting. I'm saying, can you say this one or not? Just think a little bit. Just think a little bit. Whether
Yeah, in terms of multiplication, it is not possible. But
then
if I add,
if you are not able to multiply, then how you can do the division?
but isn't addition multiplication addition many times?
No, Haridas, what I will suggest you, just after this session, think for 2 to 3 minutes. That will give you the answer. That is homework for you. Okay? If you will not get, we can discuss in the next session. I'm emphasizing on this. Just think, you will get the answer.
Yes.
Okay.
Sir, where can I get the question paper, sir? The one which you
I think
shared.
some people are saying, maybe I will ask to TAs. They will discuss some questions, question paper. They will share with you.
Sir, can't we have the access of them?
I don't think we can share here, but you can find. I will ask to TA. They will help you.
Okay, sir.
Yeah.
Sorry,
Sir,
can you
sir.
suggest me again? I got a lower network connection.
Scale of measurement, Sakshi, we have already discussed.
Sir, week 1 practice assignment 2, question number 4 have rating is a it says rating is a numerical variable here, but you have said that rating is rating is considered as
Sakshi, in
ordinal
that
variable.
question, I think you're talking about that overall rating and all, right? Average and all. Okay. So if I'm not wrong. So in that question, thing is that it's clearly mentioned we are talking about in terms of numerical. It's not like so in that question it is not mentioned one means no poor, two means good, three means no best or something like. It's clearly mentioned we are talking the ratings in numbers. Okay, it is clearly mentioned that. Okay, so if you're talking about in terms of numbers and it says it is clearly mentioned also we can calculate the average and all, then accordingly it will be I mean appropriately you can apply the scale of
Sir,
measurement.
but you have said that we can
Sakshi, that's
take
what I'm
ordinal.
saying. That's what I'm saying. When it will be ordinal, if I'm clearly saying, let's say I'm saying one means go, let's say very poor, two means poor, or three means average, four means good, five means very good. If I'm clearly coding, going to label these ratings, okay, and then it will be ordinal. If suppose I'm clearly saying I'm talking in terms of numerical values only, right? I'm not talking about anything, any what one is going to represent, two is going to represent, and something and so on, right? Then that's why they are talking about the average rating. Okay.
Okay, sir.
Yeah.
I have a
Fine.
doubt regarding ratio and interval. So you told ratio cannot be negative, but
Yes.
we had a class and in that sort of like money is ratio, because even though you can have balance as zero, but you can also have it as negative. And when it is zero means actually no money. So it can go in negative and absolute zero also exists. That's why it's ratio. So ratio can go negative, but in that zero does have a meaning, right?
What do you mean by negative?
No, yesterday, sir, like he explained the example with money, and money can example money that is deposited in a bank account. So when there's zero, it means no amount, but it can also go in a negative balance if you're taken a loan or something, not repaid. So it goes in negative balance. So negative balance is also there, zero
No,
amount.
but loan is a different scenario, right?
Yes, sir, but money can go negative, right?
But okay, first of all, can you talking about money in terms of general, or you're talking about in terms of whether you've taken the loan or something like that?
Sir,
Okay, suppose you have credit card and all, then
I don't know how this works.
okay, just search. Okay, so Kasika, thing is that we cannot generalize in. So okay, can you okay? What I'm suggesting, no, tell me. So temperature, I'm not mentioning whether it's a Celsius, Kelvin, or Fahrenheit. If I say temperature will have ratio scale of measure, whether I will be correct or wrong?
Wrong, sir.
Wrong, right? I may be correct, I may be wrong, right? We can't say. So it will depend on the scenario, Kasika. Are you getting? Suppose I'm talking about, let's say, money in my bank account or money in my pocket or something like that. Okay, then it will be ratio. Okay, so it will depend on the scenario how we are going to define. Are you getting? Let's say stock market. One day you are in profit, another day you are in loss. Okay.
Okay.
But then we can't multiply it.
And suppose you are okay, so it will depend on the scenario, right? And those things normally we are trying to clearly mention those things. Okay.
Sir, that question, there was a weekly mock question regarding the marks. Like, do that question and you get 0.5 marks for correct answer, and 0.2 is deducted the wrong answer. In that case, you can get 0 in two ways. Either one person has done two answers and both of them are wrong. So 0.2 minus 0.2 gives you 0. Or if the person has not done any questions, then also you'll get 0. So in that case, absolute 0 exists, and at the same.
Okay, Kasika, I think in that question, what is the case? They are talking about the overall marks. Overall marks can be 0, but overall marks can be negative also. Okay.
Yes, sir.
Are you getting my point? So it's not suppose I have done two questions and two wrong questions. I got 0. Okay. Suppose you have done two correct questions, you will get some positive number. Suppose someone else they have attempted few correct but more wrong, he or she will get negative marks. Okay. So it's talking about like what can be the overall marks. Okay. So it will be
Sir, in this
interval. So
question,
they are
if we, sir, in this question, if we don't attempt any question, then also we are getting 0. So it should be ratio.
So Puskar ji, it's not about whether you didn't attend any question or you didn't went to exam hall to write the exam and all. It's not about that individual scenario. It's about if you calculate the overall marks. So overall marks can go in negative. That's why it's interval. Am I right? Clear?
Yes,
It's
sir.
not like
Okay, sir.
you were not able to wake up in the morning and you didn't went to go to the exam hall or like watchman didn't give you an entry in the inside the hall due to some reason, due to late and all, you are not able to write. That's not a case. Okay, I think I'm clear.
So this means that even though like technically absolute zero will exist, but because it will go in negative, it
No,
can.
Kasika, okay, Kasika, if I will say, suppose I have scored -2 marks, for example, and you have scored 0 marks, okay? So does that mean you didn't score any marks or you scored some marks as compared to me?
I scored wrong marks, that's why I got 0 in that.
Yeah, what I'm saying, suppose you got 0, I got -2. Okay. Then what the interpretation you will make?
We got more marks than you, sir.
Something like that?
Yes, sir.
Correct. Now is it clear? So actually, in case of interval scale, go to two to three things we have to keep in mind. First of all, absolute zero property. Second thing, if say absolute zero property is not fulfilled, right? Then that's why it's taking values in negative. While if you see in ratio scale of measurement, due to that absolute zero property, it is we are able to perform multiplication and division. It can't take values in negative. Okay, so that is the key thing we have to
Okay, sir.
cross
Got
verify.
it.
Okay.
Got it.
Okay. Kasika, if you see the temperature case, right, degrees Celsius, that is a very simple example I'm taking always. So if you see 0 degrees Celsius, right, so if it can take values in negative, right, while in Kelvin it can't take value below 0, right? Are you getting my point?
Yes, sir, but that balance problem one, is that nominal or sorry, ratio or interval?
I told you, Haridas,
Interval,
it depends on the
Interval,
scenario how we are going to define, right? You can't say anything in general. It will depend on the scenario. Okay.
Sir, are we going to have like sir week 1 or week 2 or all the revision classes for each subject?
Sir, am I audible?
No, it depends on the instructor of that subject. Normally for stats 1, we are taking 1 and 2 separately, and I think if you have checked your calendar, so for week 3 and week 4 we have session on
Yes, sir, we
Thursday, right?
have. I was
Correct?
asking
Yeah.
about sir
So
maths, like if we
no,
can have it.
I'm not sure about math. It will depend on the
Instructor.
yeah, correct. How, I mean,
Correct.
what is the
Sir,
slots
Maths
available?
is there. If you see in calendar, it's there.
Yeah,
Maths
I
revision
think
session
math
1
is
and 2.
already
It is
started,
there.
if I'm not wrong.
Yeah, it's in the calendar.
I think
Okay.
math is started, right? Math session, right?
Yes, sir, but it's
sir,
all
when will
with
be
us,
our next
but not
session?
revision session.
Okay, Puskarji, I think
No,
you
no,
have.
revision session is also there. If you see on your calendar, Google
But it's
Calendar.
today is the solving session,
Yeah,
right?
yeah,
It's
today.
Yes,
not
but they have scheduled 2 sessions for revision
Yeah,
as
yeah, yeah.
well.
They.
when it is. Can you tell me? Hello,
I think you should check, Sadhu. Just
sir.
check your calendar.
I can check, but sir, it's not really my calendar. Really don't work properly.
Okay, then
Sir,
I'm not sure about
hello.
that. Yes, Kunal. Yeah, please go ahead. I think I will
Sir,
take
I
some
have a
other.
doubt in box plot actually.
Yeah, maths revision is on July 3 and 4, like tomorrow and day after tomorrow, 8 to 10, both days.
Okay, thank you so much.
Yes, Kunal. Yeah. Go ahead.
Sir, I have a doubt in box plot graph. Sir, like in box plot, we usually indicate a box and a 2-line up and down there, right?
Correct.
The upper line will indicate the maximum and the below line will indicate the minimum.
Yes.
And the middle of the box represent Q2, which is mainly
Q1, not
median,
Q2.
right?
Not Q2.
Sorry,
Q1.
Q2.
Q1.
No, sir. I'm talking about the middle of the box.
No, see it. Okay, that Q2 will not be exact in between that Q1 and Q3. It can vary according to the data.
So it will be between Q1 and Q3, right?
Yeah, it will be between that box itself, but it's not exactly at equidistant of that.
So there can be a case, sir, that Q2 and Q3 can be equal.
Okay.
So how can we plot for this?
Okay, can you tell me what Q2 represents and Q3 represent, how they will be equal?
Sir, I'm getting Q2 and Q3 value as same.
Okay.
Which is 38.
Okay. For which I think that then data set is very small, right?
No, sir. Data set is actually n is equal to 40.
40.
Yes, sir.
Okay. Can you
This is a mock
send
test
me that
question.
data set? I will mock question, right?
Yeah.
I think then you shouldn't ask like this indirectly. No, this is not the correct way to ask. You can simply mention this is from a mock. Okay.
Yes, sir. That's why I'm asking just a concept. Then how can we plot this type of graph where the two quartiles are same?
No, is it in mock test 1 or mock test 2?
It is in mock test 2.
Mock test 2. Okay, first try to mock test. Try to attend mock test 1. Okay, because mock test 1 is.
It is done, sir. It is done. I got full.
Let me see mock test 2 then. 1 second. Let me see which question you are talking about.
Sir, is this one and qualifier exam have the same syllabus, that is from week 1 to
yes.
week 4?
So yes, we are talking about question number 2, right, Kunal?
Yes, sir. Yes, sir. Yes.
Yeah, so Q2 will be in between, right? I think you are making some mistakes. If Q2 will be in between, no need to calculate the Q2. Why you are worrying about Q2? And all 4 options is given to you, right?
Yes, sir.
Yeah, you have to choose the correct one. Just calculate the Q1 and Q3. See, suppose this here you can see Q1 is 7, right? Q3
yes,
is
sir.
9.
Q1 is 7.
So
yeah.
Q2 will be in between to these two graphs. So you have to see what you have to calculate the main thing. You have to calculate the maximum. You have to calculate the minimum. You have to calculate the Q1 and to Q3. No need to worry
I calculated the all. I got the Q2 and Q3 both as 8.
No worries. Then you choose the options accordingly.
For me, I think option 2 is correct.
Then it's fine.
But sir, I'm doubt that can Q2 and Q3 can be same.
Yeah, it's fine. Yeah, because you have numbers like this, right? It's possible. That's not a problem.
Yeah, I have that doubt only. Q2 and Q10 can be Q2 and Q3 can be same or not.
Yeah, that's not a problem. Okay.
Okay.
Sir,
hello.
Yes?
Sir, actually I have a doubt, sir.
Exam have the same question.
Sorry.
Quiz 1 and qualifier exam have the same syllabus
Yes,
from week 1 to week 4.
Same question, week 1 to week 4, same syllabus.
Okay, sir. Thank you.
Yeah.
Sir, when will be our next session for revision of week 3 and 4?
Sorry.
Sir, I have a doubt, sir. Actually, there is a question which scale of have a measurement rank, sir, rank or order. So I have got answers ratio, interval, and ordinal 3, sir. It is a multi-answer question, sir. I have kept only the single option, sir, which contains both the all the 3 answers. But they have also given them individually, sir, answers.
So fine, right? It's not a problem. Order is there, right? Order means, right? So if you have ordinal data, you can order, right? If you have interval data, interval means, let's say you have, let's say 40 degrees Celsius, 30 degrees Celsius,
Yes,
20
sir.
degrees Celsius. So there is a one order, right? Order means 30 will come after 20, 40 will
Yes,
come
sir.
after 30, right? And similarly for HCU. Okay,
Yes, sir, but my doubt is if we opt them individually, but so they might be a single option, no? So actually they have given all the 3 answers in one option.
It's fine. It's fine. That's not a problem.
So we have to opt them individually also, sir.
Correct. Whatever the options are correct, you have to choose those one. Okay.
Okay, sir. I have another doubt also. Qualification of a candidate sitting for job interview, will it be a categorical or a numerical, sir?
Okay, you tell me what will be qualification?
I think it is numerical, sir.
How?
Okay, sorry, sir. It will be categorical. Is it ordinal, sir?
Okay, you tell me.
Yeah, it would be ordinal, sir.
That's fine. Clear?
Okay, sir.
Okay.
Sir, number of days a group of students take to finish school projects, sir. What it would be, sir?
Okay, you tell me. Number of dates, how will you write? 1 day?
I think it would be categorical, sir.
Why?
Because we just write the dates and we won't count it.
We are
Count
talking
them,
about,
sir.
Megha, we are talking
Yes,
about
sir.
number of days. Suppose I have completed my project in 3 days, you have completed your project in 2 days. Suppose Sakshi has completed her project in 5 days. Then
Yes,
I'm
sir.
talking about 2 days, 3 days, 5 days. It's about number of days. So it's how it will be numerical, sorry, categorical data.
Okay, sir. Then would it be discrete or continuous, sir?
Now you tell me.
This would be, I think,
You are going to count or you will measure?
We are going to count, sir.
So discrete or continuous?
Okay, sir, it would be discrete. But it there might be a chance of 2.5 days like that also. There might be a chance, no, sir.
Okay, that is the problem. See, everyone is taking individuals problem. Suppose, okay, I can say I woke up at 6 a.m. in the morning. I went to school and I submitted my project 9 a.m. and I completed my project in 2 days or some 3 hours, some 4 hours, something. That's not the case. See, I'm talking about number of days. Whether I completed in 2 days, 3 days, 4 days. It doesn't. It's not like this. I have completed whether at 11:59 p.m. or something like that. Okay. So don't think like this. So what we are doing generally, we are making the problems complicated. Okay. So that is not good. Just think it's a very simple thing. I'm talking about number of days. Okay. Suppose you are traveling somewhere and I ask how many days your train took. Then will you tell me 2 days and a half day something? You simply 1 day, 2 days, something like that. If I'll talk about hours, you will say 18 hours, some 20 minutes, 18 hours, 15 minutes, something like that. Okay, so it will depend on the scenario. All right.
Okay, sir.
Okay, yeah, fine. Okay, I think it's
Hello,
already
hello, sir.
9. We should.
Sir, I have a problem.
Your voice is breaking, Vivek. Your voice is breaking.
Hello, sir.
Yes. Hello.
Hello, sir. Vivek, go ahead.
Yeah, that's please.
Sir, I have couple of doubts. Sir, if we are just given, we are asked to find the feedback, like if we are given the data not satisfactory, some satisfactory, normal, so like that. So it is the ordinal data, right? Ordinal scale.
Yes.
So if what if we are given in some other context these rating scales as coded 1, 2, 3, 4, 5, just coded, nothing information is given. So is it ordinal or interval?
No, you are talking about you are clearly going to mention not satisfied as 1, satisfied as 2.
Yes, in subsection, subsection of question.
Yeah, then it will be ordinal. That's not okay, because you are clearly see what categorical data does. See, you are going to label that categories. That's all. You are labeling that categories. Okay, if you are clearly mentioning that categories, then it's the ordinal data set. Okay. Yeah.
Huh? Yeah. Okay.
Because
so
you are, whatever you see, you are just changing the scenario of that.
Yeah. Just labeling. I have just changes to 1, 2, 3.
How the main feature will change.
Yes, but sir, I think any of the activity question are the previous year question. I find that it is given the rating scale 1 to 5 and asked for the average rating. So in that scenario, we have to choose the option.
Okay, I will tell you it is from practice assignment. I think I'm not sure whether 1.1 or 1.2, but there it's not mentioned whether we are talking about we are labeling or not. Okay, so
okay,
don't connect those two. That is the different scenario. Okay, just please, I will request you to read. Just open that practice assignment and read the question. That is the different. Okay.
Okay. So every time if they just ask if just given the rating scale, not association of any order or anything.
Things will be
So
clearly mentioned.
we can have
Things will be
okay.
clearly mentioned. Okay.
Okay.
Yeah.
Okay. Thank you.
Sir, can you explain the area principle?
Area principle what? Where means which I'm not going to explain whole things. You should rewatch the things. But I can tell you the where you are not getting the things.
If the area is not
Pushkar, I think Sandhya should ask. Yeah. Yes, Sandhya, please. See, if you not speak where you are
Sir,
down.
I am saying that if area does not satisfy the given percentage, then it would not be area of principle.
Correct. So the whatever the area is there, right? It should correspond to the data, right? Suppose you can't make a a small slice for 50% one. Okay, I mean what I'm talking about. Suppose you can't say. Suppose I use pie chart like this. Suppose this is the pie chart. Okay, and you said this is the, let's say 30%, and you said this is the 10%, and this is the 60%. Okay, so you can't say, right? Because if you see this 10, actually 10% should be this one, while in reality 30% should be this one, right? But here it represents 10% is this one, 30% is this. So this is area principle we are violated, right? Are you getting?
Misleading graph.
Okay, so we have to keep those things in mind. Okay, and also
Sir,
some
sir,
of
I
all
have
the
a
content
question
should
in
be
pie
equal.
chart, sir. I have a question in pie chart, sir. If we have, sir, round of error like 102%, sir, so that graph is not concluded, or sir, like we will like conclude that graph or something.
No, it's a wrong thing. You have made
So, sir, it's
some error.
totally misleading
Correct.
graph. Like we
Yeah.
can't.
So we have to go with the 100% because pie charts is, see, we are comparing parts of a whole. Whole means 100%, right?
Yes,
you
sir.
can't say that whole is 101 or 102.
Okay, sir.
Okay.
Sir, when will be our another session for revising week 3 and week 4?
I think Puskarji, you should check your calendar, right? I think you just check your calendar, and also we have sent an announcement, right?
Okay.
Sir, I have
So please check that one. Okay?
regarding examination.
Next session is going to happen week 3. We are going to revise week 3 and 4 Thursday 6 to 8 p.m. So
Okay,
you can
thank
check
you
your
so much.
calendar. We have sent an out. Yeah, all right. Thank you. Okay, I think yeah. So
Sir, I have a
Sir,
doubt, sir.
I have a doubt.
yes, Vivek.
I have doubt regarding examination qualification. Sir, if I wear the image,
Your voice is breaking, Vivek. I'm not able to. You are not able to understand.
I think you should write in chat.
Yeah, you can write in chat, or if it's ops related thing, then you can write to support team.
Sir, one more request, sir. Hello. Hello.
Yeah, that's good.
Sir, one more request, sir. You have please share the PDF.
I already share in the chat box, but anyway, I will share with the support team. They will upload the PDF. Okay, no need to worry. Okay, I will share with them. I think it's already 9 p.m. today, but by tomorrow they will upload it.
Okay. Thank you.
Okay, Vivek, you can write on the
Sir,
chat.
I am having doubt.
We can discuss in the next session. Okay, it's already 9.
Okay, doubt. Just one.
Yes, Saubhagya.
Sir, I'm having doubt that in a question, for a given data, how to find that whether it can be best represented by bar graph or Pareto chart.
So you have to identify the case whether question is about the count of categories or it is representing parts or percentage in terms of percentage. So if count of categories is there, let's say for category A, category B, category C, let's say category A it's 15, category B it's 10, category C it's 5, then you will go for the bar chart. And if
if there is an ordinal data, then we will go to the Pareto chart.
No, it's not about ordinal data. You have to go for Pareto chart. For Pareto chart, we have to order the frequency. That is the difference.
Okay, sir.
Okay. So for pie chart, we are talking about in terms of percentage. Okay. Let's say sales distribution of product A in a particular company to at the end of the year. Sales distribution of product B, sales distribution of product C, something like that. Okay. Yeah?
Okay, sir.
Okay.
Okay, sir.
Okay.
Understood.
I think okay then. All right. Okay. I hope
Okay,
you
thank
got
you,
the
sir. Have a nice day, sir.
Week-1.
So last one, can
Sir,
ratio
I
scale
have
of
a doubt, sir.
measurement be negative in any scenario?
Hardas, I have already given the question, but what you are doing? Okay, you are just simply messaging again and again and again, right?
No, I'm
No.
asking if any scenario is there in which ratio can be negative.
Okay, I told you if ratio can take. This is the only possible in case of interval, not in. Okay.
Sir?
Yes.
Sir, while doing calculation in correlation and standard deviation like that, if we took after 2 decimal, it gives the same another answer. If I took after 3 decimal point,
No, Ramya. So it depends on the previous question. Previous question, suppose it mentioned you to. It's a questions are related, right? In the question, suppose it is mentioned 2 decimal places. You got 19 point. Let's say 666 three times, right? Then 2 decimal places it will be 19.67. Then you can proceed with that 19.67. Or best thing I will tell you, just go with the ratio part. I mean, suppose you are getting 160 divided by 6, for example, mean. Okay, correct mean. If you'll go with 160 divided by 6, at the end you will get the correct answer. Okay.
in the beginning itself, I used only for that.
Your voice is very low. Your voice is very low.
Beginning in starting also I used that decimal point only. I can't use another than that. While start doing
So
the
what I'm
calculation.
saying, first of all, if you want to round off right at the end, so try to round off at the end. Okay, first thing. Second thing, are you talking about that question number 2 and 3 from week 3 graded assignment?
Yes, sir. Yes, sir.
Yeah, the same thing I will explaining. So I think I have sent one solution, a handwritten solution in the Discord also. So if suppose in the mean you got 19.666, right? Then you, and it is mentioned to tell this 2 decimal place, then go with the 19.67. It will be 2 decimal places, and you can proceed with 19.67. Or else best approach is, suppose you got x bar as 160 divided by 6, then took 160 divided by 6, and at the end you will get the correct answer. Okay.
Okay, sir. Thank you, sir.
Thank you. Okay. Okay then. Thank you
Sir,
all.
sir.
And
Thank you,
all
sir.
you
Have a
got,
nice day, sir.
okay. Have a nice. Thank you
Good
all.
night.
Thank
Sir.
you.
Hello, sir.
Thank
I
you,
have
sir.
audible, sir.
Yes, Vivek. Go ahead.
Sir, I have a doubt, sir. If I attend 7th July examination and I miss
Vivek.
first time examination, then
Okay.
what
Okay.
happens?
Before you complete your question, I will simply suggest you please write to the support team, or else you can call to them. This kind
How
of
to
general query.
email, sir? Sir, how to email?
Okay, so their mail ID is support@std.iatm.ac. Okay.
Yes, sir.
Okay, so this kind of
Thank you, sir. Thank
a
you.
general doubt they will. I will share in the. I have shared in the chat. Then you can.
Yes, sir.
No,
Yes.
no, okay, no, it's not correct one second. It should be @yesterday.iatm. Let me write it again.
You can also use in dashboard.
Repeat again, sir.
One second, I'm writing the chat. Okay, I have shared. You can check it. Okay. Okay, or else you can find online also. That's not a problem. Okay. Okay. Okay then.
Okay,
All
sir.
right.
Thank you,
Thank
sir.
you.
Thank you,
Thank
sir.
you.
Have a nice
Bye.
day,
Have
sir.
a
Good
good
night.
day, sir. Good
Good
night,
night.
sir.
Good night. Bye.
Bye, sir.